Yeah, hi everyone, welcome to PrepFusion. So after covering EMFT, communication and analog in one shot, so now we are going to cover EDC. So these videos are helpful for those guys who have never studied these subjects. If you guys want to cover something in the examination, you have skipped those subjects, but you feel like that, sir, completely skipping is not a wise idea because last year EDC came on the very easier side. So if you skip these subjects completely, then it might happen that who knows they are coming on the easier side and you mess up your examination. So that's why we are bringing these videos where you can cover all these kind of subjects right from zero and something you can get in the examination hall. It's not that, sir, completely we are going to get, but some marks you can get in the examination hall. Okay, so now we are bringing this video for EDC. So the query will be that, sir, never studied EDC, can I watch? Yes, you can watch. Sir, I am weak in EDC, I have already studied it, can I watch? Yes, you can watch. Where will be the notes? Notes will be in the Telegram group with the name. I will put the name EDC one shot part 1. Now, why this is part 1? The point is, sir, why part 1? Why not part 2 as well? So, look, I don't have any requirement of likes or comments because you guys are already having the examination near, right? So, why I'm giving only part 1? Because I want to know that after studying from here, like, are you guys eager to learn more? Because EDC is different than EMFT, communication and analog. In EMFT, communication and analog, like I was giving you the derivation as well. I was telling you that from where this formula is coming and like you rarely have to remember anything. But EDC is a different subject. Okay, in EDC you might need to remember one or two formula. There you cannot ask me, sir, from where this formula came. If I am asking you to remember, you have to remember. If you ask me from where this formula came, then it will take 10 hours, right? So after studying, this video will be of 3 hours. So after 3 hours, what you guys feel like? First, you guys will let me know in the comment section that, sir, yes, we are eager to learn more, we can learn more as well. It might happen, no, that's a true. After 4 days we are having the examination, sir, and I don't feel like studying new things. It might happen, right? So like after studying 3 hours, like what is your current status? What you guys feel like that, sir, do we need to remember a lot of things, or sir, without remembering much things I can also understand the things? So sir, please bring part 2. So within 2 days only I will bring the part 2. What I am saying, at 10 a.m. I am uploading this video. Okay, you study it by 4 p.m. This is a 3 hours of video with the notes. It will take you roughly around 3 hours only. In 3 hours you can complete this video because you will be having the notes as well. So in a quicker manner you can watch this video, and in 3 hours you will be able to complete it. So after lunch you can sit, or by 4 p.m. you complete it, and after completing you comment down that, sir, yes, I have completed. What did you feel? That what was the level of content, and like how did I organize the content? Or yes, sir, I have the energy of learning more. I can spend 2 or 3 hours, or roughly around more, not more than 2 hours. Yes, sir, I can spend 2 more hours on EDC. Please bring the part 2 as well. It's not that I am having a requirement that, sir, I need this much, like that much, like, no. I will bring the part 2, but it is just that I need to know that are you guys are having more energy or not. Because if I had directly bring 5 hours of video, then it would be difficult for a lot of people. So after 3 hours, what do you think, that are you guys are having energy or not? So I will bring the part 2 as well. Otherwise 3 hours of content like this content as well will give you decent enough marks. If I talk about last year, in from this 3 hours of content, from this content only, last year 7 marks of question came. Because last year EDC was on the very easier side, no? So the guy who skipped EDC, it will be difficult for him. Like it will be very like downgrade, because it came on very easier side. EDC came on very easier side. So from this content itself, 7 marks of question came. I'm not saying that we are covering only whatever that was asked in last year. We are covering other topics as well. But are you able to understand? Right? So this part is also good enough. But you guys will let me know, yes, sir, we are having more energy, we can learn more. And you will also let me know that what is the level of content. And then I will be eager enough to make part 2 as well. Okay? And your comments will surely make me happy. And just as I at 4 p.m. I will check all the comment section, and I will get to know that, yes, sir, we have studied and now we need part 2, or sir, we have studied, this part is enough. Okay, so based on that I will start working, and within 2 days by 7 p.m. or 8 p.m. I will be uploading the part 2 as well. I will try to upload the part 2 by 7 p.m. Okay, so 4 p.m. I will see the comment, and then directly I will start working on it, and by 7 p.m. I will be uploading the part 2 as well. Is that okay for you? Okay, so I hope you have understood what you need to do. Let's get started with EDC. Okay, yeah, thank you very much. Now we will proceed with the video. Yeah, so now let's quickly see the course features of our Titan batch. So first you will be getting the complete video lectures, whatever that is required for your GATE examination in the best possible manner. You will get all the video content. The content will be of roughly around 950 hours. Also, you will be getting the doubt solving access as well. Once you purchase the course, you will be added to a doubt solving group where Anish sir and I will be personally clearing all your doubts. Like you can see the screenshot from our Titans batch only. Someone has asked the queries, and in the voice note, I clear all the doubts. If it is required, I can give the pen paper solution as well. And a lot of people are also there. They can also clear all your doubts. Then you will get the neatly written lecture PDF as well. Two kind of PDFs are there. Printable PDF is also there, and slides are also there, and that will be provided for all kind of subject. So what do you mean by printable PDF? So you can download this particular PDF and you can go to the printing guy and he will give you this kind of PDF. Okay, this is the printable PDF. That means all the printouts are available. Whatever that has been written in the notes, you can get the printout. It is having the white background. So whatever that I am teaching, that has been written in this particular notes. Okay, so you can simply annotate on the notes. You will not have to make your own notes, and it is completely written in the neat and clean manner. You might not be able to see the text, but it is completely written in the neat and clean manner. A lot of PDFs are already uploaded on the Telegram group. You can check the quality of the notes. And then these are the slides. So if someone is studying from the PC, if someone is having a tablet and he is annotating on the device itself, then he can use the slides. Slides will be having the black background. So here the notes will be having some colors, but printable notes will be black and white, so that it will cost you the minimum amount. Then you will be getting the solution to important PYQs. Whatever the important PYQs are there, all the PYQs will be solved. Along with that, you will be getting some assignment problems as well, which you need to solve on your own. And along with that, video solution will also be provided for those particular assignment problems. Also, we are framing more than 2000 test series problems. There will be subject wise and topic wise test series will be available in a particular subject. If there are 4 chapters, in those 4 chapters, if there are 20 topics, from each topic we are framing each question, and along with that, every particular question would have a video solution as well. The video solution will be made by me and Anish sir. You will get the personalized guidance as well once you enroll in the course. So bi-weekly we will conduct one live session. So we will come live and we will take up your query one by one. Okay, so one-to-one query we will take. So this is just a message from the side of Anish sir that like roughly around at 7:30 PM on Saturday or Sunday we conduct this particular session. So this session happens every 2 weeks. Bi-weekly this particular session would take place, where you can ask your queries or you can tell us about our progress, and you can ask that what next you can do in your preparation. Also, for your revision purpose, we will be giving you the short notes as well, and along with that, a lot of revision videos will also be available. So this is just one of the slide of the short notes. Okay, so these are the short notes on Fourier transform. So you can see that whatever the things that you are supposed to remember in one page only, a lot of things are written. So in that manner, you can utilize your short notes. These are not the main notes, they are the short notes. So whatever the important points are there, that has been written in these kind of notes. Then post-gate guidance and VLSI interview prep. So once you clear the gate examination, after that you need to get into the masters, or you need to get into the PSU. Then there they will be taking the interview. A lot of IITs and ISC would take your interview. So if they take your interview, then whatever the content you need to study, from where you would study, all the content will be taught by us only. Whatever that is necessary for your interview purpose, that will be provided to you. And if you are someone who is in tier 2 college or in tier 1 college, where VLSI companies would be visiting your campus for the placement or internship, then whatever the content that is required, that will be taught by us. Okay, so these many content will be there, and every year hundred of students are placed in VLSI industry from this particular platform. Educator and the subject taken. So GATE EC, all the subjects will be taken by me this year. All the subjects will be taken by me. That means Himanshu Agarwal. In GATE Electrical, all the non-core subject will be on me. Which all non-core subject? Network, analog, digital electronics, signal system, control systems, mathematics, and aptitude. As of now, control system and mathematics from my side is not available. I will start recording it in the March 2027. Okay, and control system will come in June 2027. So those 2 subjects will also be available. Already other subjects are already available. And for GATE EC, all the subjects will be taught by me only. And for GATE Electrical, all the core subjects will be taught by Anish sir. Okay, in the core subjects, measurements, EMFT, power system, power electronics, and electrical machines would come. Right? If you want to know more about the batch, then these are the detailed batch orientation video are available. GATE EC 2027 full batch orientation and GATE Electrical 2027 full batch orientation. You can simply type it on YouTube and then simply put PrepFusion here, and you will get this particular video, and you will get to know about our courses in more detail. Okay then, yeah, with that I would like to end this video. Thank you very much. Happy learning. Yeah, hi everyone, welcome to PrepFusion. So now we are going to start EDC, electronic devices and circuits. So right from the zero we are going to start. Even if you are having zero knowledge, still you will be able to understand. Okay, so already I have given the notes. Printable notes would be there. Get the printout. Roughly around 18 pages would be there. So 18 to 20 pages would be there. Have those 18-20 pages with you. Staple them. Have some rough notebook. Look at your screen and just try to understand whatever that I am teaching, and just revise from the notes in a quicker manner, and you are good to go in the examination. Last year, from whatever that I am going to teach now, last year from that particular part, 10 marks of question came. Can you believe that? Okay, so who knows, this year as well the same thing may happen, but surely I can at least, like, I can take guarantee that at least 3 to 4 marks question would be coming from here. That guarantee I can take. Okay, but yeah, it will be a bit different than those one shot video of analog EMFT communication. We have brought a one shot video on analog EMFT and communication. There you saw that, sir, I really need to remember any formula, right? There we were not remembering any formula, but here I might ask you to remember any formula. But when I say you need to remember it, I will make sure that I am giving you some trick, so the pressure on your brain will be reduced. Okay, so let's get started. Let's start studying about electronic devices and circuits. So first we need to study about electric field and potential. A lot of guys would be already knowing the meaning of electric field and potential, but still, let's get started. Okay, so let's just say this is a particular material. It could be a mobile. This mobile is a particular material. Now across this mobile, what I am doing, I am applying a voltage. I just connected a battery here. I just connected a battery across this particular mobile, right? So battery of volt V I have connected. Now what will happen? If there is a voltage, then there will be electric field. If there is a voltage, then there will be electric field. What is the meaning of electric field? Electric field is the negative gradient of potential. You don't need to remember it. Sir, what is the meaning of this particular thing? I will explain that particular thing. Okay, so electric field is negative gradient of the potential. Now what I am asking you to draw the graph of potential with respect to x. What I am asking, across this material you need to draw the graph of potential with respect to x. This is what you need to do. So let's just say I am saying this is your x equals to 0. This particular node is x equals to 0, and this particular node is x equals to L, right? Because the complete length is L. If this is x equals to 0, this will be x equals to L. Now in this particular circuit, I know that there is no potential defined. So can I say this potential is 0 volt? Can I say this is a 0 volt? I can assume 0 volt potential anywhere. If 0 volt is not defined, I can assume 0 volt anywhere. So if this potential is 0 volt, then what will be this potential? This potential will be V volt, right? If this is your 0 volt potential, then this will be V volt potential. So at x equals to 0, what is the potential you are having? V volt. And at x equals to L, what is the potential you are having? 0 volt. Basically, across this material, you have applied a battery of V volt. So here you are having V volt, and here you are having 0 volt. V volt here and 0 volt here. Is that understandable to you? So at x equals to 0, how much potential we are having? V volt. And at x equals to L, how much potential we are having? 0 volt. At x equals to 0, we are having V potential. At x equals to L, we are having 0 potential. That means what kind of graph we are getting? This kind of graph we are getting. So this is your potential versus distance graph. Potential versus distance graph. That x equals to 0, you are having a potential of V. At x equals to L, you are having a potential of 0. Now if I ask you what is the slope here? dvx, this is your y-axis divided by x-axis. So what is the value of slope? So can you find out the slope? So graph is like this, decreasing graph is there, that means slope is negative. What will be the value? Sir, graph is decreasing by a potential of V and length is increasing by L. But sir, decreasing graph is there, that's why negative sign would be there. So this is the slope that you are getting, minus V by L. So what will be your electric field? Sir, electric field, I thought that it could be a function of x. Electric field could be a function of x. It could be. It is not necessary that it will be a function of x. Let's check if it is a function of x or not. So what that would be? E of x would be minus of, what is the value of dvx by dx you are getting? Minus V by L. So what is the value you are getting? V by L. Minus minus sign will become plus. So what is the value you are getting? V by L. What does that mean? The electric field actually came out to be nothing but this potential V divided by the length. Potential V divided by the length. So what is the unit of a volt? Volt only. And what is the unit of a length. It could be meter, it could be centimeter. In EDC, we will use centimeter here. Okay, why we will use centimeter? Because the length of any material will not be very much larger, no? Right? A semiconductor, it will not be having a length of 1 meter. It may have a length of 1 centimeter, right? So that's why we will use centimeter here. Okay. So electric field is having a unit of volt per centimeter. What is the value of electric field you are getting? That is V by L. So from this slide, only thing you need to remember is that across a material, if I apply a potential V, then the electric field that would come out to be V by L. So can you draw the graph of electric field with respect to X? What I am asking you to do, draw the graph of electric field with respect to X. How the graph would look like? Sir, always it is V by L only. Sir, always it is V by L only. No matter whatever the value of X is there, the electric field is always V by L. Whatever the potential that you have applied divided by the length. If I ask you at X equals to 0, what is the electric field? You will say V by L. At X equals to 0.55, what is the electric field? You will say V by L. At this particular point, what is the electric field? You will say V by L. At this particular point, what is the electric field? You will say V by L only. So electric field is coming out to be uniform here. What did I say? Uniform. There are two words. One word is uniform and other word is constant. People think that both of the words are same. No. What is the meaning of uniform? The meaning of uniform is that one particular quantity is not a function of X. Is this a function of X? Electric field is not a function of X. So if it is not a function of X, then it is known as uniform, and if it is not a function of T, then it is known as constant. So here we are not even talking about the time. Time we are not talking about. We are only talking about function of X. So electric field is uniform, but potential is not uniform. At X equals to 0, you are having V potential. At X equals to L, you are having 0 potential. So potential is not uniform, but electric field is uniform. Did you understand this meaning or not? So at any point, if I ask you what is the value of electric field, will you be able to tell me? Yes, sir. Electric field will simply be V by L. Let's talk about the direction of electric field. What we are going to talk about? We are going to talk about the direction of electric field. So direction of electric field is always from the positive charge to the negative charge. This you might have heard. So if this is the battery I am applying, this is the negative node and this is the positive node, right? So if this is the positive node, this node will also become positive. And if this is the negative node, then this node will also become negative. This was the positive node, this node also became positive. This was the negative node, this node also became negative. So electric field will always be there from the positive charge to the negative charge. This will be the direction of electric field. So this is the direction of electric field that came out to be V by L. So across a material, I am applying a potential of V. This is how I applied the potential of V. So here I was having V potential, here I was having 0 potential. So potential was decreasing from V to 0. So what will be the value of electric field I was getting? V by L. That is the value of electric field I was getting. Now what is the direction of the electric field? So this was the positive side, this was the negative side. Direction of electric field was from positive to negative. There you go. Is this slide clear to you? Absolutely, it should be clear. Understandable? Now let's talk about metal, or let's talk about Ohm's law. So you might have heard Ohm's law. Let's just say this is a particular metal. Let's just say this is a metal. Again, what I am doing, I am applying a potential of V. What I will get? I will get some current out of it. Let's just say this material is having a resistance of R. What I am saying, this material is having a resistance of R. So I am replacing this material with some resistance R. So what will be the current flowing here? Can you write down the current? Sir, basic Ohm's law, we know that, sir, current would be nothing but V equals to IR. This is the Ohm's law that we know. But there is another Ohm's law. Do you remember it? In your class 12th or in class 11th, you might have studied it. You might have studied. If there is potential V, what does that mean? There will be electric field as well. What will be the direction of electric field? Sir, this will be the direction of electric field. And what will be the value of this electric field? So value of this electric field will be nothing but V by L. Then a very important formula is coming. Okay, very important formula is coming. Then your current density is given by sigma E. Do you remember this formula or not? Current density is given by sigma E, where sigma is known as conductivity, E is known as electric field, and J is known as current density. I hope you remember all these things. What do you mean by current density? Current density is nothing but current divided by the cross section area. You know that, sir, current will be flowing like this. So now this current will be, now this is a 3D material, no? This is the material, this is a 3D material. I have connected a wire here, I have connected a wire. So this is how the current is coming. This is how the current is coming. So current is passing this area, no? Current is passing through this cross section area. This is how the current is coming. So this particular area, which area? This particular area. Current is passing through this particular area. In 2D I am showing it, but I hope you have already understood that this is the metal. Current is passing from here. So current is passing this particular area. This area is nothing but area A. So this is known as cross section area. What A is known as? A is known as cross section area. So J equals to sigma E. This you would have surely heard in your elementary in class 11th or 12th. J equals to sigma E. V equals to IR came from here only. But what is the basic formula? Basic formula is J equals to sigma E. Sigma is the conductivity and E is the electric field. What do you mean by conductivity? The ability to conduct the current. If I say conductivity is 0, that means current cannot be conducted. If I say conductivity is infinity, that means any amount of current could be conducted. So conductivity means ability to conduct the current. That's it. Now this sigma also has a particular formula, and that is very important. Sigma. First I will write down the formula and then I will ask you to remember it by a simple trick. So what do we show here? Till this point we have seen that there will be some current across a metal. If I am applying a particular voltage V, then there will be some current. That current divided by the area. Current divided by the area, that means the current density is given by sigma into E. E is the electric field. I know that it will be V by L. Now what is the expression of sigma? Expression of sigma is N Q mu. Now what is N, what is Q, what is mu? We will talk about it. But let me tell you that how to remember this particular formula. So you might have heard this particular term in your social media, sigma male, right? Sigma guy, sigma male. This particular thing you have heard. So who is the sigma male? The guy who is unique, right? The guy who is unique. Sigma male means the guy who is unique. U, N, skip I, Q. U is nothing. U is actually mu. N, Q. That's it. This is the formula. Mu, Q, N. So what you will remember? Sigma means unique. Do you know the spelling of unique? Yes, sir. U, N, I, Q, U, E. I just need to skip this I. That's it. Mu, N, Q. That's it. Mu, N, Q. Or N, Q, mu. In whatever the manner you need to remember. As of now, you are not having much time. You will feel like that, sir, I will not be able to remember it. Just remember sigma equals to unique. That's it. Is that understandable to you? Now, what is N? What is Q? What is mu? Q is the charge. Q is the charge. What is the value of Q? 1.6 into 10 power minus 19 coulomb. It will be given in the examination, but I hope you already remember it. N is the number of electrons. Number of electrons. Number of electrons in the metal. N is the number of electrons in the metal. Now Q is the charge of electron. Charge of an electron. What that would be? 1.6 into 10 power minus 19 coulomb. And what is mu? Mu is known as mobility. What mu is known as? Mu is known as mobility. What is the meaning of mobility? Mobility is coming from two words, mobile plus ability. Mobile plus ability. That means it is the ability to walk. What I am saying? Ability to walk. Ability to move. Okay? Mobile plus ability, it is the ability to move. Let's just say there is an empty road. Okay? There is an empty road. And here there is a road where there are a lot of people. Now there is some guy, and here also there is the same guy. Now I ask him to run here. What I am saying? Run. And here also I am asking him to run. So where he will be able to run fast? On an empty road, right? Here he will not be able to run faster. Why is that so? Because there are a lot of people. So he will not be able to run faster. But here there is an empty road, so he will be able to run faster. So here his mobility is more, here his mobility is lesser. So mobility is the ability to walk or ability to move. So with what ability your electrons are moving, that is known as mobility of electrons. Okay. So is that understandable to you? So sigma equals to unique. What you need to remember? Sigma equals to unique. The only thing you need to remember is sigma equals to unique. Is that clear to you? Okay. Now let's see another thing. Let's take this metal out. I am just saying that this is the metal. Okay. Now this was the metal you are having, you have applied a potential V. Now the question is why the current is flowing. So in the material there will be a lot of free electrons, right? There will be a lot of free electrons. Now have you heard this kind of thing in your basic class 11 12th, that if there is some electric field, now in this electric field, if I place an electron, then the electron will feel the force opposite to the electric field. What I am saying, in the electric field, if I place an electron, then electron will feel the force opposite to the electric field. The force will be Q into E. Although you don't need to remember this particular expression, but electron is having negative charge, right? I hope you know this particular thing, that electron would have a negative charge. Electron always have a negative charge. Electron will have a negative charge here, but we don't show the negative sign here. But electron will have the negative charge, that's why the force will be opposite. So electron will be moving in this direction. So across this material, if you have applied the electric field which is from left to right, then where the electrons will move? Electrons will move from right to left. Electrons are moving from right to left. And if electron moves, current flow. Very important line. If electron moves, then current flows. For the current to flow, who is important? Movement of electrons are important. So if the electron is moving, if the electrons are moving, then the current would flow, and the direction of current flow is always opposite to the movement of electron. Electron will always say that I am opposite. You have applied an electric field, electron will say I will go opposite. Now electrons are going in this direction, then current will say that I will go opposite to you. So what will be the direction of current? This will be the direction of current. So isn't it the direction of current? Electrons are moving in this direction, so what is the direction of current? This is the direction of current. Look, where the electrons are moving in this direction, right? Electrons are moving in this direction. Electrons are moving in this direction. What is the direction of current? This is the direction of current. 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 So is that understandable to you? All these points are understandable to you or not? You are not mugging up anything. Till this point, what you have studied? J equals to sigma E. J equals to sigma E. Sigma equals to unique. N, Q, mu. N is the number of electrons, Q is the charge, mu is the mobility. Every value will be given in the examination hall. And you will be able to find out the value of current density. Current density, which is I by A. Secondly, what I am asking? Secondly, I am asking is that in a material or in a metal, if there are some electrons, you have applied a potential, that means there will be some electric field as well. The electrons will always move opposite to the applied electric field. And if in whichever the direction electrons are moving, the current will be opposite to that. That's it. This is the point that you need to take care. This was the question which was asked. Okay. So these are the points that has been written. What is the direction of electric field? From positive to negative. What is the direction of a electron flow? Opposite to the electric field. Direction of electron flow. So if electric field is in this direction, electron will flow in this direction. Now what is the direction of current flow? If electrons are moving in this direction, current will say I will move in this direction. Electrons are moving in this direction, current will say I will move in this direction. Is that understandable to you? Okay, well and good. So this was the question which was asked last year in a GATE EC examination, GATE 2025. Okay, this came in 2025. So solve this question. Electric field is given, electric field value is given 0.01 volt per meter is applied along the length of a copper wire of circular cross section with diameter 1 micrometer. That means this is our wire which is having circular cross section. This is the wire we are having, and the cross section of wire is circular. What is the cross section of this mobile? The cross section of this mobile is rectangular. Cross section of this mobile is rectangular. This is the cross section which is rectangular, but they are saying that it is circular and it is having a radius of 1 millimeter. Always take care of units. Okay, it is very, very important. 1 millimeter. Now you can sense that, sir, this value is given in meter only, and sir, this value is also given in meter. You can see conductivity value is given, and that is also given in meter only. Are you able to understand this point? So this is also in meter, this is also in meter, sir. Then sir, I will also convert this into as meter as well. So what is the diameter that is given? Diameter that is given is, or it is not the radius, it is the diameter. So diameter is given as 10 to the power minus 3 meter. I hope you know that 1 milli means 10 to the power minus 3. So diameter is 10 to the power minus 3 meter. So what will be the radius? Radius will be 10 to the power minus 3 divided by 2. Why I am interested in the radius? Because I know that eventually, sir, they are asking the current. If they are asking the current, that means I will have to multiply with the cross section area, because J equals to I by A. J equals to I by A. J equals to sigma E, I can apply. E value I am having, sigma value I am having. But eventually I will have to multiply with the area as well. So area will be pi r square, which will become pi d square by 4. Now, what do I remember? Sir, I need to find out the current, but I remember the formula of current density. J equals to sigma E. I know that it is nothing but I by A. So what will be the value of I you are getting? Sigma E A. Now what is the value of sigma? Value of sigma is 5.8 into 10 to the power 7. Everything will go in meters. Okay, everything is going in meters. Into, what is the value of electric field? 0.01 into pi by 4 d square. What is the value of d? Value of d is pi by 4. Area is pi by 4 d square. So pi by 4, what is the value of d square? That is 10 to the power minus 6. So that's the answer we are getting. अरे भाई क्या हो गया यार? So we just need to perform the calculation, nothing else. So 5.8 into 0.01 into pi divided by 4 into 10, 0.455. That means 0.455 or 0.46. So that would be the answer. What would be the answer? This would be the answer. Okay, very straightforward question, and surely the answer will be in ampere. Surely the answer is in ampere. Electric field was given, diameter was given, I find out the cross section area. Important part was to find out the cross section area. Current density is sigma E, right? J equals to sigma E. So I by A, sigma E into A, sigma value 5.8 into 10 power 7, value of electric field is 0.01, area is pi d square by 4. Understandable? So pi by 4 and then multiply with 5.8. Okay, let me check back the calculation again. Pi by 4 multiply with 5.8. So yeah, 0.455. This will be the answer you will be getting. So what we studied as of now, did we start semiconductor physics anywhere? No. These are the normal physics that you know in your elementary classes. Now we are going to talk about the semiconductor. What do you mean by semiconductor? So just like metal was a material, no? This metal was also a material. Right? It was nothing but a material only. So just like that, semiconductor is also a material only. Semiconductor is also a material only. Okay. So when I say metal here, it could be copper. When I say metal, it could be copper. No, copper is a metal. So when I say semiconductor, it could be silicon or germanium. What it would be? Silicon or germanium. Silicon or germanium. Silicon or germanium. Again, here also the ditto same thing. What ditto same thing? That's our again. This is the V potential. This is the positive side. This is the negative side. Electric field direction will be from positive to negative. What will be the value of this electric field? This is the electric field. What will be the value of this electric field? Sir, it will be V by L. What will be the value of current? Value of current will be sigma E. So till this point, everything is same. Okay, so this was nothing but the semiconductor. Okay, this was nothing but semiconductor. Now in metal, what did I say? That we are having electrons. In semiconductor, along with the electron, one more guy will come into action. What I said, there will be electrons. Along with that, there will be holes as well. So there will be two kind of particles. One was electron, which we already know. Another particle will also be there, that is hole. What is a hole? Hole is nothing but a vacancy of electron. It is nothing but a vacancy of electron. So hole has all the same property as electrons, but what hole will say? That I will do everything opposite to you. What I am saying, holes will have the same property. Let's just say, what is the charge of electron? What is the charge of electron? Charge of electron. Qn I am putting, charge of electron. Okay. So charge of electron is minus 1.6 into 10 power minus 19 coulomb. So charge of hole, what will be the charge of hole? 1.6 into 10 to the power minus 19 only. Okay. But this is giving negative charge, he will say I will give positive charge. Now just let me know one thing. In the presence of electric field, electron always move opposite to the direction of electric field. If this is the direction of electric field, electrons will move here. Electrons will move here. So what do you think where holes will move? Holes are having positive charge, that means holes will move here. Let's talk about the current. So what current will say? That I will flow opposite to the flow of electron. If electrons are flowing here, then I will flow in this direction. So this is the current that is coming because of the electrons. Current because of the flow of electron. Now what current will say again? Current will say that if holes are moving in left to right, if holes are moving from left to right, then I will also flow from left to right only. Are you able to understand this point? Everything is opposite. Holes are nothing but a vacancy of electron only. So whatever electron is doing, holes are doing just opposite thing. In the presence of electric field, holes will move opposite. Sorry, electrons will move opposite. In the presence of electric field, electrons will move opposite. So what holes will say? That I will move in the same direction. Now what current will say? Current will say that I will move opposite to the direction of current flow. Sorry, current will say that I will move opposite to the direction of electron flow. Electrons are moving from right to left. Electrons are moving from right to left. So current will say that I will move from left to right. Now holes are moving from left to right. Holes are moving from left to right. So what current will say? That I will also move from left to right only. So what is the total current? Total current that you are getting is electron current plus hole current. Is that understandable to you? Or you can write down current density, because you know that if I divide this by A, so what I will be getting? Current density. And for current density, what do you know? You remember a formula. Which formula you remember? That is sigma E. So both electrons and hole are having the same electric field. So who will be changing here? Who will be changing here? Sigma will be changing. So previously, what is the formula of sigma you wrote down? Sir, you wrote down NQ mu, where N is the number of electrons, Q is the charge, and mu is the mobility. But in place of mu, I am writing mu N. Why is that so? Because along with the electrons, holes will also come into action. Hole will say that I am also present. So number of holes multiply with the charge and mobility. This negative positive sign will not matter. Here no one will say that, sir, I will put minus 1.6 into 10 power minus 19 and here I will put plus. No. The point is that current is flowing in the same direction. Because of the movement of electron, the current is flowing from left to right, and because of the movement of holes, the current is flowing from left to right only. That means both of the currents are being added. So eventually I should show somewhat like this. The total current is, the current that is flowing is IN plus IP. I will again repeat it. It is very simple, very straightforward. There is a particular semiconductor. Semiconductor is having two material, electron and hole. What is this hole, sir? Hole is nothing but absence of or vacancy of electron. Whatever the electron would do, hole will say that I will do opposite. Electric field is applied, electron will say I will move opposite. Holes will say I will move in the same direction. What about the current? Current says that in whichever the direction electrons are moving, I will flow opposite to that. So electrons are moving from right to left, current will say I will move from left to right. Now what about the holes? Holes are moving from left to right. So current will say that I will move in the same direction. That means current will say that I will also move from left to right only. That means both of the currents, because of the electrons as well, because of the holes as well, both are added. So both currents are added. Is that understandable to you? So this is the total conductivity we are getting, where N is the number of electron. You know what is N? N is the number of electron. Q is the charge. Mu N is the mobility of electrons. And what is mu P? Mu P is the mobility of holes. And what is the value of, what do you mean by P here? What do you mean by P? P is the number of holes present in the semiconductor. And what is N? N is the number of holes present, number of electrons present in semiconductor. Okay, so that's the scenario. So I hope this slide is also clear to you. Absolutely, it is fine to you. Say yes or no. Let's see the type of semiconductor. So first one is intrinsic semiconductor. So how the type is defined? Types are defined based on the number of electrons and holes. Based on the number of electrons and holes. So if your number of electrons is equal to the number of holes, then it is known as intrinsic semiconductor. What I am saying, if number of electrons are equal to the number of holes, then it is known as intrinsic semiconductor. So collectively we can show them by Ni. What I am saying, collectively we can show them by Ni, and there is a specific name of this Ni which is known as intrinsic carrier concentration. You don't need to mug it up, you will be able to remember it. Intrinsic carrier concentration. Number of electrons equals to number of holes. Collectively we can call it Ni. So then it will be known as intrinsic semiconductor. That means it is a pure semiconductor. What is the other name? Other name is pure semiconductor. I have same more doctor I have written. Okay, so it is pure semiconductor. Pure semiconductor it is. Like it is purely silicon or germanium. What do you mean by pure? I will tell you. Later on I will tell you what is the meaning of pure. Is that understandable to you? So what do you think what will be the current? So if someone asks current, then what is the first thing that will click to you? J equals to sigma E. Right? This is the first thing that will click to you. Now what is the value of sigma? Sir, sigma, we are talking about semiconductor. So semiconductor will have two kind of materials. Sorry, two kind of charge carriers. We call it charge carriers. Okay, or you can say two kind of particles it will have. One is the electron, so n q mu n. Another one is the holes. So p q mu p. So two kind of particles it will have. So this is the value of sigma. But sir, we are talking about intrinsic semiconductor. In the intrinsic semiconductor, for intrinsic semiconductor, number of electrons is equals to number of holes, that is equals to intrinsic carrier concentration. So that means, sir, conductivity will be nothing but N and P both can be replaced with Ni, Q mu N plus Ni Q mu P. So what you can see here is that Ni Q can be taken common. Ni into Q can be taken common, and here what will come? Mu N mu P. So people actually remember this formula, but you don't need to remember it. You will be able to write it down in the examination hall very easily. That NiQ mu n plus mu p into E. Are you going to mug it up? Absolutely not. What do you remember? J equals to sigma E. Sigma is unique. What is the meaning of sigma male? The guy which is unique. 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 Forget this I. U is mu n q. Number of electrons, mobility, charge. Plus, if we talk about the semiconductor, so it will have holes as well, mobility, charge. There you go. You will be able to write down. Now we are talking about intrinsic semiconductor. That means N will be equals to P will be equals to Ni. So I will take Ni common and my job would be done. So very easily you will be able to solve the problems. So this will be the current density. And if you need to write down the value of current, what will be the value of current? So that will come out to be a complex formula. People will think that, sir, how we will remember the formula? But eventually you are not remembering this formula. Okay, eventually what you are remembering? You are only remembering one thing, that is J equals to sigma. Sigma is unique. So this as well you will be able to write down. What is the meaning of intrinsic semiconductor? That also you know. N equals to P equals to Ni. Okay, understandable? So this was your intrinsic semiconductor. Then there is another semiconductor which is known as P-type semiconductor. So P-type semiconductors are made from intrinsic semiconductor only. So what really happened was, when we used the intrinsic semiconductor and when we calculated the value of current, this current was actually very low. What really happened? We took an intrinsic semiconductor, we took silicon and we calculated its current. We applied some potential across a particular length and then we saw that value of current is coming out to be very low. So if value of current is very low, then that means it is not helpful for us. It is not useful for us. Then what we did? We made this P-type semiconductor. So what we did was that it was an intrinsic semiconductor only, but in this intrinsic semiconductor, we did the doping of trivalent atoms. Now, who are the trivalent atoms? Trivalent atoms are boron, aluminium, gallium, indium, thallium. Look, do you remember boron, carbon, nitrogen? Right? Boron, carbon, nitrogen, do you remember? In periodic table, boron, carbon, nitrogen. So here what will come? This is how I used to remember. Bangan, alu, gajar, in thela. Okay, I don't know what is your way. So you can remember. Okay, here it will be carbon, silicon, germanium, and whatever it is, whatever that is downward, I don't care. And here New Zealand, Pakistan, Australia, sub BK. So it is nitrogen, phosphorus, arsenic. This is bismuth, and what this is? Antimony. Okay. nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, so this is known as trivalent atoms. Why is that so? Because carbon will have 4 electrons, nitrogen will have 5 electrons, and they will have 3 electrons. So what they are known as? Trivalent atoms. And what they are known as? Pentavalent atoms. So what we did the doping of either boron or aluminum or gallium or indium or thallium. So I am saying that I did the doping of boron here. Okay, so boron was having 3 electrons. That means he was having a vacancy of electron. Like here in this intrinsic semiconductor, who was present? Silicon was present. In this intrinsic semiconductor, silicon was present. So silicon was saying that I am having 4 electrons. Then who came? Then boron came. Boron is saying that I am having only 3 electrons. That means I am having one vacancy of the electron. And if you are having one vacancy of the electron, that means you are increasing the number of holes here. What you are doing? You are increasing the number of holes. So when you did the doping of boron, the number of holes got increased. And holes are positively charged carriers. That's why it is known as p-type semiconductor. Holes are positively charged carriers. Hole means charge will be positive. 1.6 into 10 power minus 19 plus. So that's why it is known as p-type semiconductor. Okay. So we did the doping of boron atom. And how many boron atoms? So we did the doping of Na boron atoms. Na boron atoms per unit volume. What is the meaning of it? Per unit volume. Let's just say I have done the doping of Na equals to 10 atoms per centimeter cube. Per centimeter cube. What is the meaning of this? That means in 1 centimeter cube volume, I am putting 10 boron atoms. In 1 centimeter cube volume, I am putting 10 boron atoms. Is that understandable to you? So that means here number of holes got increased than the number of electrons. Do you understand this point or not? So here what really happened? The number of holes are much greater than the number of electrons. So again here also, if someone asks that what is the value of current, J equals to sigma E, again what you will do? In the intrinsic semiconductor, what you have done? You have in the intrinsic semiconductor, what you have done is that you have done the doping of boron atoms. Na boron atoms. What do you mean by Na? Na means acceptor atoms. N means number of atoms. A is acceptor. Acceptor atoms. Why I am calling it acceptor? Because boron is having only 3 electrons, no? And it is having one vacancy. That means it can accept the electrons. This boron guy can accept the electrons. That's why we are calling it acceptor atoms. What is the meaning of Na? Acceptor atoms. So we have doped 10 acceptor atoms per unit volume. Because of that, 10 new holes will come into action. So number of holes has got increased. So now this intrinsic semiconductor, after the doping, what it will become? After the doping, now it has become a p-type semiconductor. A p-type semiconductor. It has become a p-type semiconductor. And in this p-type semiconductor, the number of holes are greater than the number of electrons. If someone asks me what will be the current, I will say it is nothing but J equals to sigma E. No one can change it. J equals to sigma E. No one can change it. What is E here? Assuming that I am applying a potential V across it. Ditto same scenario. Nothing different here. Ditto same scenario. There is an electric field. There will be a potential V. All the scenario is ditto same. Electric field here. Sorry, you are applying a potential V here. You are applying a potential V here. This potential V here. So this will be the electric field you will be getting. Electric field will be nothing but V by L. Right? Right? So everything is same. Now in this semiconductor you are having holes as well and you are having electrons as well, but holes are much more than the electrons. Electrons are very less, holes are more. So what will happen? In the presence of electric field, holes will move here, electrons will also move. So that means current will be there because of both electrons and holes. NQ mu N plus PQ mu P. The same scenario, NQ mu N, PQ mu P. But here the point is that P is much greater than N. That means this term could be ignored. You can ignore this term. Okay, so I am calling this as conductivity of intrinsic semiconductor. So now I am saying conductivity of a p-type semiconductor. What that would be? This term could be ignored. That would be pq mu p. Very simple thing. Nothing new you have studied here. So again, what will be the current density in p-type semiconductor? That would be sigma p into electric field. What that would be equivalent to? pq mu p into E. And here I am calling this as current density of intrinsic semiconductor. Is that understandable to you? So to make a p-type semiconductor, what you need to do? You need to dope trivalent atoms. Boron, aluminum, gallium, indium, thallium, anything would work. Now what we will make? The same scenario, and now we are going to make a n-type semiconductor. So for n-type semiconductor, what I will do? I can do the doping of aluminum, sorry, not aluminum, nitrogen, phosphorus, arsenic, bismuth, or antimony. Okay, so let's just say I have doped phosphorus atoms here. So what it is known as? It is known as donor atom. Why is that so? Because phosphorus will say that I am having 5 electrons. Carbon, what carbon said? Sorry, what silicon said? Silicon said that I am having only 4 electrons. Phosphorus is saying that I am having 5 electrons. That means he is the donor. He can donate the electrons. So Na donor atoms per centimeter cube or per unit volume we have doped. So P stands for phosphorus here. So in place of using phosphorus, let's assume arsenic, because people will be getting confused. P means they will say that it is a p-type semiconductor. No. So in place of phosphorus, what I have put? Arsenic. Okay. So arsenic has been doped here, which is having 5 electrons. So he can donate the electrons. So he is the donor. So what it will become now? It will become n-type semiconductor. Now he is the donor. That means he is having one extra electron. He is having one extra electron. That means here more electrons will be there in this n-type semiconductor. And why it is known as n-type semiconductor? Because electrons are negatively charged. That's why it is known as n-type semiconductor. So more electrons and lesser holes. More electrons and lesser holes. Again, here also the same thing. We will apply the electric field. We will get the current. Ditto same scenario. Nothing different. J equals to sigma E. Everything is same. Sigma value is also same. It's just that number of electrons will be much more than the number of holes. Number of electrons is much more than the number of holes. If I ask you what is the current, current is nothing but J equals to sigma E. What is the value of sigma? Sigma is nq mu n plus pq mu p. Right? Now n is much greater than p. N is much greater than p. That means this will be ignored. So what do you see? Conductivity in n-type semiconductor, or that would be nq mu n. Why is that so? Because this guy could be removed, because it is much lesser than n. So nq mu n you will be getting. So what will be the conduction current density you will be getting? nq mu n into E. There you go. That's it. So again the simple thing, very simple thing. Whatever that you have already studied, these things are only there. Nothing new is there, right? So let's see the questions of last year. So this was the question that was asked. Now I have just changed one modification I have done, and I am asking another question. So first let's solve whatever that was asked. Here what they are asking? Resistivity. What do you mean by resistivity? Sir, this term I don't even know. So resistivity is nothing but the reciprocal of conductivity. Resistivity is nothing but reciprocal of conductivity. Okay. So resistivity is rho I, which is simply the reciprocal of conductivity. So you need to find out the reciprocal of conductivity. So resistivity is drawn by rho I. So here only I am telling the concept. Now what you need to find out? You need to find out for the intrinsic semiconductor, you need to find out the conductivity. Sir, what is conductivity? Conductivity is sigma. Sigma is unique. Sigma male unique. N q mu n. Unique. U and I q. I need to ignore. So n q mu n. But sir, we are talking about semiconductor. That means p q mu p will also come. In place of n, I can put p as well, q, mu p, this will also come. Now we are talking about intrinsic semiconductor. That means, sir, n equals to p equals to ni. So what I will get? So conductivity will be ni, I will put here, q is also common. So ni into q, mu n plus mu p. There you go. Sir, value of intrinsic carrier concentration is given. Yes, sir. Intrinsic carrier concentration is given. That is 2.5 into, just see the unit, 2.5 into per meter cube. Always take care of the unit. So 2.5 into 10 power 16. What is the value of q? 1.6 into 10 power minus 19. What is the value of mu n and mu p? So they are also given. See the unit, meter square, volt second. Everything is SI unit. No need to worry about it. So electron mobility is 0.15 and hole mobility is 0.05. So 0.15 plus 0.05. There you go. This is the value of conductivity you are getting. Okay. So what will be the value of conductivity that you are getting, that we need to see. So this is 10 to the power minus 3, 2.5 into 1.6 into 0.2, 0.8. So what we are getting? 0.8 milli. Now what will be the unit of conductivity? Can anyone tell? What will be the unit? J equals to sigma E. What is this? Ampere per meter square. Current divided by area. Ampere per meter square. What is electric field? Volt per meter. Meter get cancelled out. What is ampere per volt? Look, we are talking about sigma. So ampere per meter per volt. So ampere per volt into meter. What is ampere per volt? Ampere is I by V. What does that mean? 1 by R. That means it is 1 upon ohm into meter. Is that understandable to you? So what you are getting? Ohm into meter. So this is 0.8 milli, or you can say 0.8 into 10 to the power minus 3. 0.8 into 10 to the power minus 3 ohm per meter. Okay. Or ohm meter inverse. Ohm meter inverse. Now what you need to do? You need to take its reciprocal. So what will be your resistivity? Resistivity will simply be reciprocal of 1.08 into 10 to the power minus 3. So when you take the reciprocal, what you are getting? You are getting 1.25 into 10 to the power 3. This is what you are getting. Right? This is the answer that you are getting. Now what was the unit here? Ohm per meter. So what will be the unit here? Ohm into meter. But in what unit we need to tell the answer? Kilo ohm meter. So 1.25 10 to the power 3 could be written as kilo ohm dot meter. Kilo ohm dot meter. Not per meter, sorry. Kilo ohm dot meter. So this was ohm meter inverse. Ohm meter inverse. When I took the reciprocal, it became ohm into meter. 10 to the power 3 means kilo. So what is the answer we are getting? 1.25. So 1.25. Is that understandable to you? Resistivity is nothing but the reciprocal of conductivity. Conductivity formula, sir, I already know. If you already know the formula of conductivity, your job is done. Just see the intrinsic semiconductor, N equals to P equals to Ni, put the values, job done. Always in examination, you will feel like that, sir, EDC question is very lengthy, they are tough. But the question might be lengthy, but they are actually easy. You just need to pick up the data and put it there. That's it. So lengthy question doesn't mean that it is difficult. They will just be lengthy, language will be lengthy, but simple formula based question they will be. Okay. Now if I say that there is a applied electric field of 2 volt per centimeter and there is a cross section area of 1 centimeter square, or better I should put 2 volt per meter and cross section area of, or let's put centimeter only. Applied electric field is 2 volt per meter. Okay. This is the applied electric field which is 2 volt per meter and the cross section area is 1 centimeter square. Then what will be the drift current? Now what is this drift word, sir? So if there is a current, because of the applied potential, because of the electric field, if there is a current, what really happened here? There was an electric field, right? So because of the electric field, if current is flowing, then the current is known as drift current. So whatever the formula that we studied as of now, this current, this was also a drift current. Drift current density. We used to call it current density, but better name would be drift current density. What is the meaning of drift here? Drift means in the presence of electric field. In the presence of electric field. So this was also drift. So here what we wrote? J was current density. In place of that, we should have written J is nothing but drift current density. In the presence of electric field. In the presence of electric field, If some current is coming, then that is known as drift current. Because of the electric field it is coming, that's why it is known as drift current. Is that clear to you? So if there is an applied electric field of 2 volt per meter and cross section area is given, you need to find out the drift current. So what do I know? Sir, J equals to sigma E, right? And I equals to sigma E into A. So what will be my answer? Sigma value is already there. What is the value of sigma? 0.8 into 10 to the power minus 3. SI unit is there. What is the value of electric field? 2 volt per meter. SI unit is there. What is the value of area? Area is 1 centimeter square, which will be written as 10 to the power minus 4. What is the meaning of centimeter? Centimeter means 10 to the power minus 2. But square is there, that means it will become 10 to the power minus 4 meter square. So this is 10 to the power minus 4 meter square. So what you are getting? 1.6 into 10 to the power minus 7 ampere, which could be written as 160 nano ampere. That would be the answer. Is that clear to you? Okay. So always take care of unit. In EDC, always take care of unit. Sigma E into A. Sigma value I have already calculated here. 0.8 into 10 to power minus 3 we were getting. So I just put it here, right? Into 2, which is the electric field, multiply with the cross section area, 10 to the power minus 4, 10 to the power minus 7, 1.6. So here I can multiply with 10 to the power minus 2. So here also I will multiply with 10 to the power 2. So it will become 160 nano ampere. That would be the answer. Okay. So this question was asked, but this could also be asked. Let's go to the next one. Which of the following can be used as an N-type dopant? So if this kind of question is coming in my examination, what I will think? Sir, boron, carbon, nitrogen. Here, silicon, germanium. Here, there you go, right? This was for P-type. Because, why they are for P-type? Because they are trivalent atoms. That means they are having one vacancy. Vacancy means holes. So this was for P-type. And they are having one extra electron. Extra electron. That means negative is there. Negative means electrons. That means that this was N-type. So for N-type, what you can use? You can use nitrogen, phosphorus. Phosphorus. Can you use gallium? Gallium is used here. Can you use boron? Boron is used here. Then you can use arsenic. There you go. This is the answer. So this was also asked in 2025. This was also asked in 2025. And one question before we saw, this was also asked in 2025 only. Okay, well and good. Let's move ahead. We will study a law called mass action law. Okay, mass action law. So I will take a break and then I will come back. What we are going to study? Mass action law. So what it says actually, in any kind of semiconductor, whether it is a intrinsic semiconductor or it is a N-type semiconductor or it is a P-type semiconductor, in any kind of semiconductor, number of electrons multiplied with the number of holes will always be constant. And that would be equals to Ni square. Do you remember what was Ni? Number of electrons multiplied with the number of holes will always be constant and it will be equals to Ni square. Do you remember what was Ni? Ni was the intrinsic carrier concentration. So for intrinsic semiconductor, number of electrons were equals to the number of holes and they were equals to Ni. Ni is known as intrinsic carrier concentration. So here only if you do N into P equals to N into P. So what you will get? Ni into Ni. What this will become? Ni square. Basically, N into P equals to Ni square is valid for any kind of semiconductor. Sir, for intrinsic it is completely visible. Yeah, it is surely visible. Why is that so? Because number of electrons are equals to number of holes and that is equals to intrinsic carrier concentration. But what about N-type semiconductor and P-type semiconductor? So the actual scenario was that this was my intrinsic semiconductor. This was my intrinsic semiconductor. In this intrinsic semiconductor, what I did the doping. I did the doping of a donor atom. What I got? I got N-type semiconductor. Now in this N-type semiconductor, what did I say? That number of electrons has increased. Number of electrons has increased. What about the number of holes? Did they remain same? No, they did not remain same. They actually got reduced. Why is that so? Because I know that number of electrons multiplied with the number of holes, that has to be constant. Let's just say previously here in this intrinsic semiconductor there was 10 electrons. So if it is intrinsic, then let me know what will be the number of holes. That will also be 10. In the intrinsic semiconductor, I am saying that this is the scenario of intrinsic semiconductor. So what I am saying, in the intrinsic semiconductor there were 10 electrons. So let me know what will be the number of holes. They will be equal. So N equals to 10, P equals to 10. So what is the product? N into P is 100. Now what I did the doping of donor atoms. When I did the doping of donor atoms, what really happened? The number of electrons became 20. So can you let me know what will be the number of holes? Sir, it will be 10 only. No, it will become 5. Why is that so? Because 20 into 5, I need to maintain constant that is equals to 100. Is that understandable to you? This is your mass action law. In any kind of semiconductor, your number of electrons multiplied with the number of holes will always remain constant. If you know the number of electrons, then you can surely tell the number of holes as well. From intrinsic only you are getting n-type. How did you get n-type semiconductor? From intrinsic semiconductor you got the n-type semiconductor. How did you get p-type semiconductor? From intrinsic semiconductor only. So intrinsic semiconductor will say that whatever the multiplication was there, number of electrons multiplied with the number of holes, that will remain constant no matter what. Whatever the doping you are doing, I don't care about it. So if your number of holes are increasing, number of electrons will go down. And if number of electrons are increasing, the number of holes will go down. Is that understandable to you? This is known as mass action law, that the multiplication of number of electrons and number of holes will always remain constant, that is equals to Ni square. Is that understandable to you? So how did you get the n-type semiconductor? You did that doping of Nd donor atoms. Okay. Now there is a scenario. Now I have done the doping of Nd donor atoms. Now I ask you how many electrons you will be having in your n-type semiconductor. Let's just say this was my intrinsic semiconductor. I don't know what was the number of electrons holes. I don't care about it. This was my intrinsic semiconductor. Now in this intrinsic semiconductor, what I have done? I have done the doping of 10 donor atom per centimeter cube. 10 donor atom per unit volume. Now I ask you how many number of electrons it is having. The answer will be 10. Okay, so approximately the number of electrons in n-type semiconductor will be equal to the number of donor atom that you have doped. If you have doped 10 donor atoms, then the number of electrons will become 10. If you have doped 20 donor atoms, then the number of electrons will become 20. 30, it will become 30. It is the approximated formula. Exact formula is something else. That exact formula is not important for your examination. Till this date, they never asked the exact formula. They always asked this approximated formula only. We will solve the numerical. It will become more clear to you. Have some patience. Okay. Have some patience. It will become clear to you. Intrinsic semiconductor I was having. Now I did the doping of 10 donor atoms. Now I ask you, what is the number of electrons you are having? You will say 10. And now I ask you, what is the number of holes you are having? What will be the answer? You already know that n into p equals to Ni square. Now you know that n is equals to Nd. So what will be the number of holes you will be getting? That will be Ni square divided by n, or Ni square by Nd. So this is the scenario for n-type semiconductor. What about for the p-type semiconductor? Now you already know that in n-type semiconductor, number of electrons will be more than the number of holes, right? So these electrons are known as majority charge carriers, and p are known as minority charge carriers. Okay. So here what is the scenario? P will be much greater than n. So it is known as majority charge carrier, and what this is known as minority charge carriers. So in p-type semiconductor, who is the majority? Holes. And who is the minority? N. And n-type semiconductor, who is the majority? Electrons. Who is the minority? Holes. Is that understandable to you? By the name as well, it is clear. Understandable? Right? So here in the intrinsic semiconductor, if I have done the doping of Na acceptor atoms, then what will be the number of holes I will be having? The number of holes I will be having will be Na. And what will be the number of electrons I will be having? That will be Ni square by Na. Why is that so? Because I know that number of electrons multiplied with the number of holes will be Ni square. So number of holes I will be having, that is equals to Na, and number of electrons that I will be having, that will be Ni square by Na. Sir, whatever all these things is there, sir, it feels like that I need to remember much of the things. No, very rarely you need to remember anything. Only thing you need to remember is multiplication of number of electrons multiplied with the number of holes, that will be equals to Ni square. That will remain constant. So in intrinsic semiconductor, you are having n number of electrons and p number of holes, and they were equal. So n into p equals to Ni square. From the intrinsic, you are making n-type semiconductor. That means you are doping 10 donor atoms, or whatever the number of atoms you are doping, So they will become the number of electrons. Now if you know the number of electrons, you can find out the number of holes. Similarly, in p-type semiconductor, what is the number of acceptor atoms you are doping? So the acceptor atoms you are doping is Na. So you already know the number of holes, then you can find out the number of electrons as well. N into P equals to Ni square. We will solve the numerical, it will become absolutely clear to you. This is the numerical. An intrinsic semiconductor has an intrinsic carrier concentration of 1.5 into 10 power. Ni value is given 1.5 into 10 to the power 10 centimeter cube inverse. So previously, when it was intrinsic semiconductor, it was having 1.5 into 10 power 10 electrons and 1.5 into 10 power 10 holes. Now what I have done, in the semiconductor, I have doped boron atom. Now boron is an acceptor atom or donor atom? It is an acceptor atom. Boron is having only 3 electrons. 3 electrons means it will make a p-type semiconductor. So I have doped boron atom concentration of 5 into 10 to the power 16. So now what they are asking? They are asking in the doped semiconductor, find out the concentration of electron and holes. So it is a p-type semiconductor. What I have understood, it is a p-type semiconductor. What is the doping I have done? I have done the doping of acceptor atoms of 5 into 10 to the power 16 centimeter cube inverse. So can you let me know what will be the number of electrons I am having, or sorry, what will be the number of holes I am having? So I told you in a p-type semiconductor, the number of holes you are having is approximately equals to the doping that you have done. So how much doping you have done? You have done the doping of 5 into 10 to the power 16 centimeter cube inverse. Now if you know the number of holes, can you find out the number of electrons? Yes sir. So when it was intrinsic, N into P was equals to Ni square, this will always remain. So number of electrons multiplied with the number of holes will always be equals to Ni square. So from here, if someone asks me what will be the number of electrons, so number of electrons will be nothing but Ni square divided by P. What is the value of Ni square? Value of Ni square is 2.25 into 10 to the power 20, right? 2.25, 1.5 into 10 to the power 10, so 2.25 into 10 to the power 20 divided by number of holes. What that is coming out to be 2.25 divided by 5. So 0.45 into 10 to the power 16 centimeter cube inverse. So what do you see here? What did you see here? That your number of holes were 5 into 10 to the power 16 centimeter cube inverse. This was the number of holes, right? And what was the number of electrons you were getting? 0.45 into 10 to the power 16 centimeter cube inverse. This was the number of, sorry, this is 10 to the power 4. Really sorry guys. This is 10 to the power 4, right? 0.45 into 10 to the power 4. So 0.45 into 10 to the power 4. 0.45 into 10 to the power 4 centimeter cube inverse. So you can see here that P is much greater than N. P is much greater than N. Look here, you see 10 to the power 16, 10 to the power 4. 10 to the power 16 means 16 0 are there. And 10 to the power 4 means only 4 0 are there. So this value is much larger than this one. If you are having only roughly around 4500, but here you are having 5 into 10 to the power 16, which is much larger value, right? It is 10 to the power 12 times more. Understandable? So this was the intrinsic carrier concentration. You had the number of, you know that what was the doping. So doping was done with the acceptor atoms. That means it became p-type. Now for the p-type, who is the majority? Holes. Who is the minority? Electrons. So for finding out the majority of carriers, that means for finding out the holes, what I can do, whatever the doping that you have done, that will be equals to the number of holes, which will be equals to Na. And what will be the number of electrons? That will be number of electrons multiplied with the number of holes will always be constant. That will be equals to Ni square. If I know the number of holes, I can find out the value of number of electrons as well. Say yes or no. Very easy, very straightforward. Do the second question on your own. You will be able to do it very easily. Same question it is, but this time you are doing the doping of arsenic atom. You are doing the doping of arsenic atom. What does that mean? Sir, when I am doing the doping of arsenic atom, that means the donor atom is 5 into 10 to the power 16. What does that mean? The number of electrons will be equals to Nd only, and that will be 5 into 10 to the power 16 centimeter cube inverse. So what will be the number of holes? So I know that N into P equals to Ni square will always remain. So number of holes will be Ni square by P, and that, sorry, number of holes will be Ni square by N. So I will put the value of Ni square. Ni square is nothing but 2.25 into 10 to the power 20 divided by 5 into 10 to the power 16. So what is the value you are getting? 0.45 into 10 to the power 4 centimeter cube inverse. So this is the number of holes you are getting. So you can sense here is that N is much greater than P, which is surely telling that it is a N-type semiconductor. Is that understandable to you? Is this concept clear to you or not? Well and good. Okay, very basic concept we are seeing. Now this is a different kind of question. Here you are doing the doping of a boron atom as well, and you are doing the doping of arsenic atom as well. Okay, so we will solve this kind of question, but let me take a break. I will take a break and then I will come back. You will not be able to solve it actually. You can try it, but you might not be able to solve it. You need to see who is the majority. You can see that boron is larger than the arsenic. What does that mean? That means that acceptor atoms is larger than the donor atom. What does that mean? This semiconductor will become p-type semiconductor. It is known as compensated p-type semiconductor. The name is compensated p-type semiconductor. So what will be the number of holes? So previously I used to write down number of holes will be Na. Number of holes will be equals to Na, P equals to Na. But now it will be, Nd is also there, no? So it will be Na minus Nd. So what is the value you are getting? What is the value of Na? Value of Na is 5 into 10 to the power 16. Look, always go for the majority. What I mean to say is that you know that now, sir, I have got, it is a p-type semiconductor. So what will be my first matter of concern? My first matter of concern will be the majority. Who is the majority here? Sir, I know that in p-type semiconductors, sir, majority will be holes. So now my matter of concern will be that do I know the formula of number of holes? Yes, sir, it will be equals to Na. But there is Nd as well, so Na minus Nd. So Na minus Nd, what you will be getting? You will be getting as 4 into 10 to the power 16 centimeter cube inverse. This is the number of holes you are having. Right? 5 into 10 to the power 16 and 4 into. Now if I know the number of holes, what do I know? Number of electrons multiplied with the number of holes will always be constant. So number of electrons will become Ni square by P. What is the value of Ni square? Ni square was 2.25 into 10 to the power 20 divided by P, 4 into 10 to the power 16. So 2.25 divided by 4 and then multiply with 10 to the power 4 as well. So it is coming out to be 5625. 5625 centimeter cube inverse. So this was the number of electrons, this was the number of holes you were having, and number of electrons is coming out to be 5.625 into 10 to the power 3 centimeter cube inverse. Is that clear to you? Very simple thing, right? Based on this, you try solving this particular problem as well. Try solving this question. This is asked in GATE PYQ only. This is a GATE PYQ, okay? In which year I don't know, but this is a GATE PYQ. So try solving this particular problem. I will take a break and then I will come back. Okay? And you comment down as well that how you are feeling. Yeah, welcome back. So did you try this question? Arsenic atoms are given and boron atoms are given. So arsenic is the donor atom, right? Arsenic is the donor atom. So it is having a concentration of 3 into 10 to the power 18 centimeter cube inverse. And boron is the acceptor atom. It is having a concentration of 2 into 10 to the power 16 centimeter cube inverse. Okay, complete ionization and also, what do you think here? Who is dominating? The donor ones. If donor one is dominating, what does that mean? It is a N-type semiconductor. So if it is a N-type semiconductor, who is the majority now? Who is the majority? Majority are electrons. So who I will care about it? I will care about the majority, which is electrons. What that would be? Nd minus Na. What is the interesting part here? 3 into 10 to the power 18 minus 2 into 10 to the power 16 you are doing. This is very much lesser than this guy. Here both were comparable, no? 5, 1. Both were comparable. 10 to the power 16, 10 to the power 16. But here, one of the guys is 10 to the power 16, one of the guys is 10 to the power 18. How would you solve it? Let's just say I take 10 to the power 16 common. What I have done? I have taken 10 to the power 16 common. So what I will be left with here? 300. Because it is 10 to the power 18. So 3 into 10 to the power 2, 10 to the power 16. So 300 minus 2. What you are getting? 298 into 10 to the power 16. Which can be written as 2.98 into 10 to the power 18 centimeter cube inverse. So number of electrons are coming out to be 2.98 into 10 to the power 18, which is approximately equals to Nd only. What was the value of Nd? 3 into 10 to the power 18. Here what you are getting? 2.98 into 10 to the power 18. Approximately equals to Nd. right? So if ND NA difference is very much larger, then you can ignore the NA as well. If difference is very much large, okay, so here it is almost 100 times. So this is considered as a large difference only. So number of electrons, if I am having, can I find out the number of can I find out the number of holes? Yes, sir. Number of electrons multiplied with the number of holes will always remain constant, that is equal to Ni square. So it will become Ni square divided by number of electrons. So Ni square is 2.25 into 10 to the power 20 divided by number of electrons, that is 2.98 into 10 to the power 18. So what is the answer we are getting? 2.25 divided by 2.98 into 10 to the power 2. So 0.75 into 10 to the power 2 centimeter cube inverse. That's the value we are getting. Well and good. Okay. Let's solve this question. Try doing it again. It is asked in GATE examination. You can do it. Okay. Have some patience. Use your brain. You will be able to do it. From the discussion on intrinsic semiconductor, the whole concentration is given as. अरे भाई ये क्या बोल दिया? Language is incorrect. Let me see the language again. Okay. Actually, I asked the ChatGPT to write down these questions because PrepFusion is not having its own PYQ book. We are thinking to launch it this year. We might be launching PYQ book of PrepFusion. It is not certain because PYQ book is not a requirement for a lot of students, right? Already there are a lot of PYQ books. The requirement is solutions, right? So solutions we will bring. As of now, it might happen that we are not going to bring the PYQ book this year. Soon we are going to launch, but questions are available to everyone. The concern is solution, so solution we will bring. But as of now, I need to see what is the problem with this question. Yeah. So just remove all this part. For the intrinsic semiconductor, okay, what is written? For the intrinsic semiconductor, for extrinsic semiconductor, the whole concentration is given as, this is the whole concentration is given. If this is the whole concentration, can you find out the electron concentration? Yes, I know that number of electrons multiplied with the number of holes will be equal to Ni square. So number of electrons will be Ni square by P. What that would be equal to Ni square divided by 1.5 Ni. What is the answer I am getting? Ni divided by 1.5. So number of holes were 1.5 Ni. Number of electrons were Ni divided by 1.5. Right? Now what they are saying, for equal electron and hole drift current, what is the electron drift current? So that would be N Q mu N into E multiply with the area. J equals to sigma E. J equals to sigma E. If I need to find out the current, what will happen? I equals to sigma EA. What is the value of sigma? Sigma unique N Q mu E A. So N Q mu N E A. And what is the whole drift current? Whole drift current is P Q mu P E A. Right? Number of holes multiply with Q, multiply with the mobility, electric field multiply with the area. They should be equal. They should be equal. If they are equal, then what is the ratio of mu n by mu p? Electron mobility to hole mobility. That means they are asking what is the ratio of mu n by mu p. This is the question. Okay. So what we need to do? NQ mu n EA should be equals to PQ mu p EA. So E and E will get cancelled out, A and A will get cancelled out, Q and Q will get cancelled out. What you are getting? N mu n equals to P mu P. Right? So mu n by mu P is coming out to be what? Mu n by mu P is coming out to be P by N. So what is the value of P? Value of P is 1.5 Ni. What is the value of N? Ni by 1.5. What is the answer you are getting? 2.25. This is the answer. 2.25. Okay. Q get cancel out, E cancel out. Number of electrons, number of holes, mu n, mu p. N into mu n, p into mu p. Mu n by mu p you need. Mu n by mu p you need, that will be equals to p by n. Number of electrons, sorry, number of holes, that is 1.5 Ni. Number of electrons, that is Ni by 1.5. So what is the answer? What is the answer you are getting? 2.25. And I know that this answer is correct only. Yeah. Okay. Very easy question it was. Very straightforward. Just write down whatever that you know. Just equate them and get the answer. EDC is a easy subject if you just write down whatever that is mentioned in the problem. Otherwise, you will think that the problem is very lengthy. But it is not lengthy. You just need to write down the things that you already know. And you will be able to solve it. Now we are going to see a term which is known as drift velocity. Okay. Now what is the meaning of drift velocity? Let's just say this is an n-type semiconductor. In this n-type semiconductor, there will be electrons as well, there will be holes as well. Although electrons will be much more than the number of holes. If there is one hole, then electrons might be 3, right? So number of electrons will be much more than the number of holes. I have applied a potential V. What is the meaning of potential V? That means there will be an electric field as well. So in the presence of electric field, what will happen? Electrons will move. Electrons will move opposite to the electric fields, holes will move in the direction of electric field. So now they are moving, right? Electrons are moving, holes are moving. That means they will be moving with some velocity. They will be moving with some velocity. Electrons are moving. If they are moving, that means they are having some velocity. That velocity is known as drift velocity. So in the presence of electric field, the velocity of electrons or holes are known as drift velocity. So in the presence of electric field, the velocity at which electrons are moving, that is known as electron drift velocity, and the velocity at which holes are moving, that is known as holes drift velocity. So drift velocity is shown by Vd. The formula is mu e. Mobility multiplied with the electric field. So what is the formula? Vd equals to mu e. Like there is no derivation, you need to remember it. Even if someone is doing the full course, he will also remember the formula. Vd equals to mu e. That's it. Vd equals to mu e. Drift velocity equals to mu e. If you can remember, it is fine. If you cannot remember, then you can drop it. Okay, so drift velocity, very simple formula. Electric field multiplied with the mobility. Okay, Vd equals to mu e. So if I need to write down drift velocity of the electrons, what that would be? Mu n into e. And what will be the drift velocity of the hole? That will be mu p into e. Very simple thing. Drift velocity, very straightforward concept. Mu e. Mu into e. Okay, let's solve this question. A DC voltage of 10 volt is applied across a n-type silicon bar of length 1 centimeter. So this is your n-type semiconductor. They can either call it silicon bar or they can call it semiconductor as well. So it is your n-type semiconductor which is having a length of 1 centimeter. It is having a length of 1 centimeter. And it is having a rectangular cross section. That means cross section area is rectangular. Okay, cross section area is rectangular. This kind of cross section it would be having. I don't need to make the 3D structure, but I can make the 3D structure as well. It is having a rectangular cross section like this. Okay, so it is having a donor concentration Nd equals to 10 to the power 16. So is that equals to the number of electrons? Yes, sir. Donor concentration is given, that is equal to the number of electrons only. Right? So that is equal to the number of electrons. And let's just say now in this question, someone would say that, sir, I need to find out the number of holes. So for finding out the number of holes, what you will do? N into P equals to Ni square. Now, sir, Ni value is not even mentioned. That means it will be empty. No. If it is not mentioned, by default, you will take that number of holes are very less. You will say number of holes are 0. If Ni value is not mentioned, you know that Nd would be equal to the number of electrons. Number of holes will be very less. It will be equal to 0, nearly equal to 0. Because you know that, sir, whatever the question that we solved here, number of electrons is coming out to be 10 to the power 18. Number of holes is 10 to the power 2, which is much less compared to number of electrons. So if it is an n-type semiconductor, then you can say that only electrons are present, although holes will also be there. Practically they can never be zero, there will be some amount, right? But we can consider them as zero. Although let's see the question might be saying something else. So what is there? We have applied 10 volt battery. We have applied 10 volt battery here. What we are supposed to find out? Mobility is given, mobility of the electrons are given. What we are supposed to find out? Assuming a uniform electric field and a steady state drift, find the average time taken by the electrons to travel from one end to the other end. Time taken. What is the formula of time? Distance upon speed, right? Distance upon speed, right? What is the distance it will cover from one end to the other end? How much distance it will cover? 1 centimeter divided by the speed, which will be the drift velocity, right? So this will be the time taken. Can I find out the drift velocity? Yes sir. What is drift velocity? So that is nothing but mu1 into E. Do I have the value of mu1? Yes sir. 1000 into E. What is the electric field? How much voltage you are applying? 10 volt. So 10 volt divided by 1 centimeter, because what is E? E is nothing but V by L. Do you remember this thing? On the first slide we studied, E is V by L, voltage divided by the length. So 10 volt divided by 1 centimeter. Notice one thing, this is also in centimeter, volt, centimeter, this is also in centimeter, everything is going in centimeter, distance is also in centimeter. So all the calculation we are doing in centimeter. So final answer will come in seconds only. Centimeter will get cancelled out. Are you able to understand this point? Right? This is centimeter square, volt per volt second. So only second will be left eventually. Only second will be left. So here all the calculation, if you are doing in meter, then do all the calculation in meter. If you are doing in centimeter, then do all the calculation in centimeter only. So we are doing it in centimeter. So we are getting 10 to the power 4. This is 10 to the power 3. Mu1 is 10 to the power 3. What is electric field? 10 volt per centimeter. 10 volt per centimeter. So 10 volt divided by 1 centimeter. So we are getting 10 to the power 4 volt per centimeter. 10 to the power 4 volt per centimeter, that is the electric field. Then it is multiplied with mu1 as well. So drift velocity, what will be the unit of a velocity? That will be centimeter per second. And you can check as well, like what is the unit of mu1? That is centimeter square divided by volt into second. And what is the unit of electric field? That is volt per centimeter. So what you are getting? Volt to volt is getting cancelled out, centimeter to centimeter is getting cancelled out, centimeter per second. So what you are getting? Centimeter per second. So here we are getting 10 to the power 4 centimeter per second. So 1 centimeter divided by 10 to the power 4 centimeter per second. So what is the time taken we are getting? Time taken we are getting is 10 to the power minus 4 second, or it could be written as 100 microsecond. 10 to the power 4 could be written as 10 to the power 2 multiply with 10 to the power minus 2 multiply with 10 to the power minus 4. This will become 1 only. So this will become 10 to the power minus 6, which is micro. So 100 microsecond. That is the answer. Okay. This is also a gate QIQ. This also has been asked in gate only. So mostly all the gate QIQs we are solving. 70% of the gate QIQs we will solve from certain topics, right? Not from the whole EDC. But if EDC is coming on the easier side, then I can tell you one thing, that 70% of the question will come from this session only, if it is coming on the easier side. Okay, so distance upon speed, speed is 10 to the power 4 centimeter per second, then answer you are getting is 100 microsecond. Is that understandable to you? So this kind of question could be framed from drift velocity. So did you understand the meaning of drift velocity? Mu1 into E. That's it. Okay. Let's just say they are asking current density, but they did not give you the value of mu1. Okay, and they did not give you the value of electric field as well. How will you find out current density? Sir, I know that current density is nothing but sigma E. What is sigma? Sir, NQ mu E. What is mu E? Mu is nothing but Vd. Is that understandable to you? So this sometimes they can simply mention the drift velocity as well. So you should be able to solve it. Although I am not going to write it down in the examination, this much brain should be working, that if drift velocity is given, I know the formula, something I can apply. Is that understandable to you? N-type semiconductor, I only consider electrons only. P-type semiconductor, I might consider only holes. I will forget about the electrons. Why is that so? Because they are in the very less quantity, they can be ignored. Well and good. Let's go to the next one. Now let's write down the formula summary, whatever that we have studied till this point. Okay, all the formula summary. J equals to sigma E, where E is the electric field, sigma is the conductivity, J is the drift current density. Now what I will call it? Drift current density. And sigma is the conductivity. Do I need to write down anything else? And what is the value of electric field? Electric field is negative gradient of potential. In our case, mostly it is coming out to be V by L. Okay. What is the value of conductivity? For semiconductor, there will be two kind of particles, electrons and holes. Sigma equals to unique, U and Q, NQ mu n plus PQ mu P. For metal, in metal, I will only consider the electrons only. So NQ mu n. For intrinsic semiconductor, I know that sir N equals to P equals to, for intrinsic semiconductor, what is the meaning of intrinsic semiconductor? For intrinsic semiconductor, N equals to P equals to Ni. That means what will be the conductivity? Conductivity Ni can be taken common. So Ni Q mu n plus mu P. N type semiconductor, N will be much greater than P. What will be the conductivity? It can be taken as NQ mu n only, because this part could be ignored. And for P type semiconductor, P is much greater than N. So what will be the conductivity? It could be taken as PQ mu P only. What is the meaning of mass action law? No matter whatever the kind of semiconductor you are using, number of electrons multiplied with the number of holes will always be Ni square. For the intrinsic semiconductor, always number of electrons will be equal to number of holes, that is equal to Ni. For P type semiconductor, number of holes will be roughly equal to that doping that you have done, and number of electrons will be equals to Ni square divided by P, or Ni square by Na also you can write down. Ni square by Na, because number of holes will be equal to the doping. And what about N type semiconductor? So number of electrons will be equal to the doping that you have done. Here you are going to dope donor atoms, here you are going to dope acceptor atoms. So what will be the number of electrons? What will be the number of holes here? That will be Ni square divided by the number of electrons. Ni square by Nd. This is your N type semiconductor. Well and good. And then we studied about drift velocity. Only simple formula, Vd equals to mu e. Vd equals to mu e. Now in EDC we study a lot of graphs actually. Okay, with respect to temperature, conductivity with respect to temperature, mobility with respect to temperature, drift velocity with respect to temperature. All these graphs we study. In the further examination, what I feel is that only one graph could be coming, which is conductivity versus temperature. I highly expect that in the next examination, if they ask any graph, that would be conductivity versus temperature. So you are going to remember, okay, if I start explaining the graph, it will take roughly around 2 to 3 hours for all the graphs. But here you need to remember the final output, okay, because I am highly expecting that conductivity versus temperature graph would be coming. So what kind of graph it would be? Rising, going down, and then rising again. That's it. In the examination, in place of sigma, if they write down ln sigma, is there any problem for you? No. If sigma is rising, that means log will also rise, no? 2 is greater than 3. Log 2 is also greater than log 3. Sorry, 2 is greater than 3. Brain fade. 3 is greater than 2. So ln 3 is also greater than ln 2. Right? So in place of sigma, if they write down ln sigma, no problem. In the examination, what they can do? They can ask the same graph with respect to 1 by t as well. Okay? What they are asking? ln sigma with respect to 1 by t. Sigma with respect to t increases, decreases, increases again. Sigma with respect to 1 by t. If this graph is given, can you draw this graph? At high temperature, you are having very high value. So 1 by t, high temperature means it will be somewhere here. So you are having very high value. So from high value, it is decreasing, then increasing, and then decreasing. So what will happen? From high value, it is decreasing, then increasing, and then decreasing. Again, let me draw the graph. If a graph of x versus y is given, which is somewhat like this. Now I need to draw the graph of x versus 1 by y. Can I draw it? Start from here. Decreasing, increasing, decreasing, increasing. So what I will do? Starting from the maximum, decreasing, increasing, decreasing, increasing. This kind of graph I will get. So similarly here as well, the same kind of scenario is there. Start from here. Start right from the infinity. Decreasing, increasing, and then decreasing. So starting with the maximum, decreasing, and then increasing, and then again decreasing. Is that understandable to you? Just the opposite of this graph. Simple mathematics. Sir, how this graph came, conductivity versus temperature, I don't know. Although I know, but I'm not going to explain. It will take a lot of time, 2 to 3 hours it will take. You cannot do it, right? But very high expectation. I'm really expecting that if the question is coming on graph, next year they will ask this particular graph only. Conductivity versus the temperature. Increases, decreases, increases. That's it. If they are asking versus 1 by t, more probability is that they will ask this graph only, versus 1 by t. So what will happen? Decreasing, increasing, then decreasing. So just remember this graph. If you remember this graph, you will be able to draw this graph as well. This graph is easy to remember. Start from here, then in this manner. If you are remembering this graph, then start from the maximum, decrease, increase, decrease. Start from the maximum, decrease, increase, decrease. That's it. So this is the important graph. So kind of in the conclusion only I am writing down, no explanation, nothing. But again, I feel like that if the question on graph is coming from EDC, then this is the graph most probably they will ask, because all other graph which has been mentioned in Donald A. Neiman, that has been asked. Only this particular graph is not asked yet. So highly I am expecting that this particular graph is coming in your upcoming examination. It could be 2026, 2027, 2028, 2029, I don't know. But next time this graph is coming. Okay, well and good. Now sir, where this graph will go? This graph will keep on going down. When 1 by t becomes infinity, 1 by t becomes infinity. When 1 by t becomes infinity, that means when t becomes 0. When t becomes 0, it will become 0. Right? So at infinity, it will become 0. So it will keep on going down like this. So this is the graph. Okay. Starting from the maximum, decreasing, increasing, decreasing. Starting from the maximum, decreasing, increasing, decreasing. So this graph is easy to remember. Increase, decrease, increase. So this graph you will be able to make. Now basic discussion on energy we are going to do. The discussion on energy which you have already studied in a network analysis. Very basic discussion. Do you know what is energy? Energy is nothing but a charge multiplied with the voltage. If there is 2 Coulomb charge which is there in the potential difference of 5 volt, then what is the energy you are getting? 10 into Coulomb volt. And what is the meaning of Coulomb volt? Coulomb volt is nothing but joule. Better I should write down Coulomb. I will write down 2 Coulomb into 5 volt. So what you are getting? 10 Coulomb volt. And what is the meaning of Coulomb volt? Coulomb volt is nothing but joule. So Q into V. Have you ever heard this formula? Charge into potential difference. What do you get? Energy, right? Now there is an electron which is having a charge of E. It is placed across potential difference of V. Then find out its energy. Okay, what they are asking? Energy you need to find out. Electric field is denoted by this sign. This is your electric field. And when I am using this kind of E, that means it is energy. Okay. So your energy is, electron is having a charge of V, which is placed in potential V. So what is the energy you are getting? This is the energy you are getting. Now they are saying that take the charge to be 1.6 into 10 power minus 19 Coulomb. Okay. And potential to be 1 volt. It should be mentioned that potential you need to take 1 volt. V you take 1 volt. It is mentioned that V you take as 1 volt. Okay. So I am taking V as a 1 volt. So what is the answer I am getting? 1.6 into 10 to the power minus 19 Coulomb into volt. Coulomb into volt, what is that? Joule. So either you say that my energy is EV. Okay. Either you say that my energy is EV, or you can call it 1 EV. Or you say that my energy is 1.6 into 10 to the power minus 19 joule. Both are the same thing. And what is the meaning of EV? EV is nothing but it is known as electron volt. What it is known as? Electron volt. Okay. What is EV? EV is known as electron volt. So there are two units of energy. Units of energy. Units of energy. There are two units of energy. First one we always know, sir, it is joule. But in EDC, who is more famous? Joule is famous? No. In EDC, electron volt is famous. What is the meaning of electron volt? That means 1.6 into 10 to the power minus 19 Coulomb charge is accelerated by 1 volt potential difference. This is the meaning of electron volt. And 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. You don't need to remember it, but only thing from this particular slide, what do you learn? You learn that energy is having an unit of electron volt. Is that understandable to you? Now let's see the next question. if an electron is having energy of 2.5 electron volt, what is the energy? 2.5 electron volt. Then determine the potential difference across which the electron has been placed. This is the energy. What is the formula of energy? Charge into potential difference, right? Charge into potential. That is coming out to be 2.5 electron volt. Now what is the charge of electron? That is E only. So E into potential is coming out to be 2.5 electron volt. Now E and E can get cancelled out. So what is the potential you are getting? 2.5 volt. There you go. That means if some energy is mentioned x electron volt, then I ask you what is the potential across the, what is the potential associated with this energy? You will say x volt. So unit of energy is electron volt. From this energy I directly ask you what is the voltage, what you will say? X volt. Is that understandable to you? So formula of energy is Q into V. What is the unit? Unit is electron volt and joule. And energy value in electron volt is equals to the voltage in volts, right? It is pretty obvious that if an electron was having an energy of 2.5 electron volt, then the potential was 2.5 volt. So if I say that a particle is having x electron volt energy, then what is the potential associated with it? You will say, sir, x volt. Is that understandable to you or not? Okay. This slide is clear, like there is nothing. E equals to QV. We understood that there is energy is having a unit of electron volt. 1 electron volt is nothing but 1.6 into 10 to the power minus 19 joule. Okay. And if there is x electron volt energy, then what will be the potential? X volt will be the potential. There you go. Now there is something called thermal energy. What is the meaning of thermal energy? So at room's temperature as well, let's just say this is a material I am having. In this material there are some electrons. Now I did not do anything. I did not apply any battery, nothing. This material is there. It is put in the room's temperature. It is just simply put here. It is there in my hands. Now all the electrons inside it, whatever the electrons are there inside this particular material, they will have some energy without even any external excitation. That without even applying any battery, they are having some energy. Without any potential, they are having some energy because of the temperature, and that energy is known as thermal energy. Okay. So energy of a charged particle at room's temperature, that is known as thermal energy. Okay, thermal energy at room's temperature. So room's temperature is not necessary. At some temperature, energy of a charged particle at some temperature. At some temperature. So because of the temperature as well, the particles can get some energy. Just because of the temperature. Okay, so that energy is given by, you don't need to remember this formula, kT, where K is the Boltzmann constant. Boltzmann constant. And T is the temperature. So when you put up all these values at room's temperature, what is the meaning of room's temperature? At room's temperature, that means at T equals to 300 Kelvin. When I calculate this value came out to be 25.9 electron volt. So your thermal energy is 25.9 milli electron volt, not electron volt. This value came out to be 25.9 milli electron volt. So this is the thermal energy at room's temperature. So at room's temperature, an electron will feel the energy of, electron will have an energy of 25.9 milli electron volt. Okay, did I say 2.5? I don't know. It is actually 25.9 milli electron volt. Do we need to remember it? Yes. Remember what is the energy you are having. If you are not able to remember 25.9, can you please remember 26? At least remember 26. Is that understandable to you? Can you please remember 26 milli electron volt? At least this much you will be able to remember. Say yes or no. So at room's temperature, the energy of a particle is 26 milli electron volt. If I ask you, this is the thermal energy. If I ask you what will be the thermal voltage at room's temperature, thermal voltage at room's temperature, will you be able to tell me what will be the thermal voltage at room's temperature? So that would be nothing but it would be 26 millivolt. There you go. The thing is, at 300 Kelvin, you are having thermal voltage at room temperature, that is 26 millivolt. Can anyone tell at 350 Kelvin what will be the thermal voltage at 350 Kelvin? Can anyone tell? Can anyone think of it? You know that, sir, energy is proportional to T. Thermal energy is proportional to T. So your thermal voltage will also be proportional to T. If it is proportional to T, so can I say, sir, it will be equals to 350 multiply with divided by 300 multiply with 26 millivolt. Can I say this? How did I do it? Sir, Vt1 would be equals to T1 divided by Vt2 equals to T2. I need to find out the value of Vt2. What that would be? T2 by T1 into Vt1. T2 is 350. T1 is 300. Vt1 is nothing but 26 millielectron volt. Basically, at a particular temperature, I will remember the value. At 300 Kelvin, I remember the value. Now, if they ask me at any other value, I will be able to determine, because I know that it is proportional to temperature. So, thermal energy at room temperature is 26 millielectron volt. So, thermal voltage at room temperature is 26 millivolt. If I need to determine it at some other temperature, can I do it? Yes, sir. Just simply multiply with the temperature divided by 300, you will get your answer. I don't know whatever the answer is, that is not important, but the concept is important. So I will just revise whatever that we have studied. Okay, don't worry, don't feel like that, sir, there are a lot of formula, this thing or that thing. No, nothing like that. So 30.33 millivolt we are getting. So let's just see what we have studied here. Till this point, everything was clear, right? This was just the conclusion we have studied. Now new things we are getting to know. Energy is nothing but charge into voltage. Okay, this simple formula based question came in instrumentation, right? Now we go to know that there is another unit of energy, that is electron volt. Okay. Now if I say if a particle is having x electron volt energy, then what is the potential associated with that? That is x volt. Now what is the meaning of thermal energy? At room temperature, because of the temperature only, a particle will have some particular energy. So at 300 Kelvin, he will have the energy of 26 milli electron volt. Okay. So what will be the voltage? That will be 26 millivolt. Just you need to remove this E sign. So that will be 26 millivolt. Now at 300 Kelvin, this is the scenario. So at 350 Kelvin, what will be the scenario? You know that it is proportional to the temperature. That means if temperature rises, then your energy will also rise. So it is proportional to the temperature. So simply 350 divided by 300 multiply with 26 millivolt. That will be the answer you will be getting. Proportional with the temperature. That means linearly it will rise. So if linearly it is rising, so 350 divided by 300 into 26 millivolt. Job done. Okay, well and good. So all these are some prerequisite of some concept that we are going to study. So till this point, whatever the semiconductor we were discussing, we studied about N-type semiconductor, we studied about P-type semiconductor, and we studied about intrinsic semiconductor. So how did I make the N-type semiconductor? There was an intrinsic semiconductor. In this intrinsic semiconductor, what I did? In this intrinsic semiconductor, what I did the doping of a donor atom. When I did the doping of donor atom, what did I got? I got N-type semiconductor, right? I got N-type semiconductor. So here, when I was doing the doping, I was doing the doping uniformly. That means if I am putting 5 electrons here or 4 electrons here, that means 4 electrons here also I am putting. If 4 electrons here, then here also 4 electrons. Here also 4 electrons. Here also 4 electrons. Here also 4 electrons. That means everywhere the doping is uniform. Till this point, we were discussing the case of uniform doping. Is that clear to you? From intrinsic semiconductor, how did I make the N-type semiconductor? By doing the doping of a donor atom. So doping was uniform till this point. But what is the meaning of non-uniform doping? Again, you will do the same process. What you are having? Intrinsic semiconductor you are having. What you will dope? You will dope the donor atoms. What you will get? This kind of structure. What is this kind of? What is this? This is your N-type semiconductor. This is the non-uniform doping. What does that mean? That means, let's just say here you are having 4 electrons, but you have done the doping in this manner that here you are having only 3 electrons. Here you are having only 2 electrons. Here you are having only 1 electrons. Or here you are having 4 electrons. Here you are having 5 electrons. Here you are having 3 electrons, 2 electrons. In that manner, you have done the non-uniform doping. So did you understand that difference between uniform doping and non-uniform doping? So till this point we have studied all the cases of uniform doping. Is that understandable to you? And now we are going to study the case of non-uniform doping. Okay, so again I need to drink some water because I am having some problem in the throat. So I will drink some water and then I will come back. So non-uniform doping we are going to understand. You have understood the basic meaning of non-uniform doping. So let me drink some water and then again I will come back. We will continue the discussion. And if you did not comment down yet, please comment down that how you are feeling as of now. Yeah, welcome back. So let's get started. So what we were studying about, uniform doping and non-uniform doping. We understood that uniform doping means all the electrons are doped in a certain manner, like everywhere the doping is same, but here the doping is not uniform. Here there are more electrons, here there are lesser electrons, right? So it is not necessary that you are going to understand it with respect to n type. You can understand it with respect to p type as well. In p type, what will be the scenario? Uniform doping means everywhere same holes, right? And what is the meaning of non-uniform doping? That sir, here there are more number of holes, here there are lesser number of holes, here there are lesser number of holes, or here sir there are a lot of holes and here there are lesser holes. So this is the meaning of non-uniform doping, right? Very simple thing. So uniform doping we have understood and non-uniform doping we have understood. So let's see some scenario. What will happen in the case of non-uniformly doped n-type semiconductor? Okay, so this is the uniformly doped n-type semiconductor, and this is the non-uniformly doped n-type semiconductor. Here you are having more electrons, here you are having less electrons. Let's just say there are 4 benches in the classroom, and each bench is having 4 seats or 3 seats. Okay, each bench is having 3 seats. So in this bench 3 guys are sitting, in this bench 2 guys are sitting, and in this bench only 1 guy is sitting, and here there is no one sitting. What will happen now? These guys will say that what they will do, they will try to move, right, from denser region to, they will try to move to rarer medium. Like this happens with everyone, no? Like this is our mentality. We will from crowded region to, we will go to the less crowded region. Let's just talk about this DO. If I put the spray here, then the particle of this spray here they will be more, and in the room they are lesser. But what will happen? They will be spread out, right? Here there will be more quantity of the spray particles. In the room there will be lesser particles. So we will always move from the denser medium to the rarer medium. Here there is high density, here there is very less density. So what will happen here? Here there are more number of electrons, here there are lesser number of electrons. So these more electrons will start traveling towards the less number of electrons. Is that understandable to you or not? So here there are more number of electrons. These more number of electrons will start traveling towards the less number of electrons. That means these electrons will start traveling here. And if the electron travels, the current flows. So this we are understanding about n-type semiconductor. So if the electrons are traveling, the current would flow. So electrons are traveling in this direction from left to right. So current would flow from right to left. Now, is this current coming because of the electric field? No, there is no electric field here. No, we did not apply any electric field. So this current is coming because of that diffusion. What this process is known as diffusion. So this is, I am writing down diffusion current density. What I am writing down? Diffusion current density. Okay. So what you are writing down? Diffusion current density you are writing down. So what is your diffusion current density? Diffusion current density, there is a certain formula. This we are looking at for p-type for n-type semiconductor. Highly doped, rarely doped. What will happen? Electrons from the higher doped region, they will move towards the lesser doped region. Higher doped to lesser doped. That means this is how they will move. And if they are moving in this direction, what does that mean? That means there will be a current flowing in the opposite direction. Is that understandable to you? Okay. Now, do you remember the formula of drift current? Yes, sir. J equals to sigma E. What was the sigma? Sigma unique. N Q mu E. So this was the formula of drift current. So what will be the formula of diffusion current? This Q remains as it is. Q remains as it is. In place of this mu, there will be a word called dN. This is known as diffusivity. Here it was mu n, no? So here what will come? dN will come. And in place of n, is there any electric field? No. So ignore electric field. So in place of this n, what will come? dnx by dx. What is the meaning of this dnx by dx? Here this nx was same, no? Like if I ask you to plot the electron concentration with respect to x, You will say, sir, here also there are 4 electrons, here also there are 4 electrons, 4 electrons, 4 electrons, 4 electrons. So if I ask you what is the slope here, you will say, sir, slope is 0. Slope is 0. That means here also 4 guys, here also 4 guys, here also 4 guys, here also 4 guys. No one will move. Concentration is same everywhere. They are not going to move. But here there is concentration gradient. This is known as concentration gradient. So here there is more concentration, here there is lesser concentration. So these guys will move. That means if I ask you to plot this nx versus x here, nx versus x here. So can you plot somewhat like this? Nx versus x here. The plot is like this, that here there are more electrons, then there are lesser electrons, lesser electrons, lesser electrons, and lesser electrons. Although here I did not show the electrons, I can show the electrons here as well. So here there are more electrons, then lesser electrons, and lesser electrons. So this is how I can draw. That means some slope will be there. So this value will be non-zero. So will you be able to remember this formula? Will you be able to remember this formula or not? So here what I am going to put? I am going to put, if I draw the graph of nx versus x, nx versus x. So the graph would look somewhat like this. Okay, and here the slope is 0. Right? So how will you remember the formula? Sir, for drift current, I remember the formula, that is J equals to sigma E. What is sigma? N Q mu E. Right? So mu remains as it is. In place of, sorry, Q remains as it is. In place of mu, diffusivity is coming. What is the meaning of dn here? Diffusivity of electrons. And don't worry about the formula. We will again and again apply the formula, and you will be eventually remembering it. Don't worry about it. Okay? Don't worry about the formula. Eventually you will remember. Don't worry about it. Okay? Diffusivity. So in place of mu n, who is coming? dn is coming. Now in place of n, what will come? Differentiation of nx will come. Differentiation of n with respect to x. Because you know that we are talking about non-uniformly doped n-type semiconductor. What does that mean? What is the meaning of non-uniformly doped? Non-uniformly doped means, sir, there are somewhere there are more electrons, somewhere there are lesser electrons. So this is the meaning of non-uniform doping. So you will be able to write down the formula. Okay, just go by the basic formula that you remember. Drift formula we remember, J equals to sigma E. Sir, this is the diffusion current, but from there I can write down the formula, J equals to sigma E n q mu n E. Sir, Q remains as it is. In place of mu, dn comes, and in place of n, dnx by dx would come. What about the electric field? Electric field is not even present. So this is that diffusion current that you are getting. Is that understandable to you? So this was for n-type semiconductor. For p-type semiconductor as well, the formula will be same. Okay, in the same manner you will get the formula. What will be the formula? In place of q, q only. In place of dn, what you will put? dp. And in place of dnx by dx, what you will put? dpx by dx. But there you will put a negative sign. Why you are putting up a negative sign? You will understand when we solve the numerical. Why this negative sign is there? You will understand when we solve the numerical. It is not important, but we will understand it when we are going to solve the numericals. Okay, as of now, don't worry about it. Can you write down the formula of diffusion current for p-type semiconductor? Yes, sir. This I already know. Q dp dpx by dx. Q dp dpx by dx. Similarly, here diffusion current density for n-type semiconductor. What was that? Q dn dnx by dx. And what is that diffusion current density for p-type semiconductor? Q dp dpx by dx. If you forget the formula, how we are going to remember? There will be a negative sign here. How we are going to remember the formula? Sir, I remember drift current. Sir, what was that? Sigma into E. Sigma was unique, nq mu E. Sir, Q remains as it is. In place of mu, some other guy D is coming. E is not even present. I don't care about it. Mu is replaced with D. Q as it is. And what about this guy? dnx by dx. Similarly, for p-type semiconductor, it was pq mu E. So E is not even there. Q remains as it is. In place of mu, D is coming. And here dpx by dx. Just a way to remember the formula. Okay. Well and good. Right. Let's solve the numericals now. This was asked in gate 194. So free electron concentration nx, free electron concentration profile nx is in a doped semiconductor at equilibrium is shown in the figure. What is the meaning of equilibrium? What is the meaning of this word equilibrium? That means there is no external bias. What is the meaning of equilibrium? That means there is no external bias, like you are not applying any voltage V. So this is your semiconductor. What they are saying is that this is your semiconductor. Okay. So in your semiconductor at point A, in your semiconductor, this is the point A, this is the point B, and this is the point C. So at point B, they are saying that there are a lot of electrons. Okay, here there are lesser electrons, here there are lesser electrons, and concentration is going down. So if here there are a lot of electrons, here there will be these many electrons, then it is going down, and here also this is the scenario. Is that understandable to you? This is the concentration at B maximum, then here lesser, right? Now A, B, C, three different points are marked. Now for a X between B and C, for somewhere here, the electron diffusion current is directed from C to B. What does that mean? Sir, here there is more concentration, here there is lesser concentration. So how the electrons will move? Electrons will move from B to C. And if electrons are moving from B to C, so what will be the direction of a diffusion current? That will be from C to B. So if I pick any point between B and C, for X between B and C, the electron diffusion current is directed from C to B. Yes. They are talking about the current. So electrons are diffusing from higher concentration to the lower concentration. But the direction of current would be opposite to that. Direction of current would be opposite to that. Higher concentration to the lower concentration. So the direction of electron flow is from B to C, but the direction of current flow will be from C to B. Similarly, what about between B to A? So electron flow will be there between B to A. Electron will be flowing from B to A. So where the current would flow? Current would flow from A to B. Because higher concentration to the lower concentration. Electrons are flowing from B to A. So current will flow from A to B. So for any X between B to A, the they are talking about the drift current here. Now you don't even know about drift current, so you will not be able to solve all other option, right? You will not be able to solve all other option. I will talk about the drift current. What is this drift current? I will let you know. Okay, but as of now, you don't even know that how this drift current is coming. So let's pause here. Okay, let's pause here once, because I did not even explain the drift current. No, let's explain the drift current. Let me explain the drift current here. Okay, it is very interesting scenario. So this was your non-uniformly doped p-type semiconductor. Here there were more electrons, here there were lesser electrons. So what really happened? Electrons were moving from here to here, right? From a place electrons are going. From a place electrons are going. What does that mean? That place will become positively charged, right? And at some place electrons are coming. What does that mean? That place will become negatively charged. From some place electrons are going. You are releasing the electrons. That means you will become positive. And at some place electrons are coming. What does that mean? That will become negative. Is that understandable to you? Fine? All good? Now answer me one thing. Sir, here you said that there will be a diffusion current without even applying any external source. Let's just say this is the material. This is the material I am having. Here there are more electrons. Here there are lesser electrons. This is the material I am having. Here there are more electrons. Here there are lesser electrons. Electrons are diffusing. Because of the diffusion of electron, you are saying that current would come up. Without even external supply, you are getting some current. Is that possible? Like let's just say you went to the market, you got copper. You are having some copper. Okay, and you did not even apply any external source. You do not even give it a voltage. Can the current flow? Current cannot flow in open circuit. No, how the current would flow? You need to give some external energy, no? This is the rule of universe. If you want to get some energy, you need to give some energy. Right? If I want the comment from your end, that means I need to teach you. Then only you will comment down, right? So you need to give some energy, no? What is the energy you have given? You did not give any energy. There was higher doping, lesser doping. Electron flow, current is flowing. But how this current can flow? But because of the electron flow, current would be there. What does that mean? That means there will be some opposite current which is cancelling out this particular current. Is that understandable to you? So what really happened here? When electrons are moving in this direction, this side is becoming positive, this side is becoming negative, and because of that, there is a electric field build up, and that electric field is known as built-in electric field. In the semiconductor, electrons moved from left side to the right side. Because of the concentration gradient, more electrons, lesser electrons, they started moving. This side became positive, this side became negative. So inside the semiconductor, we have got a built-in electric field. What is the name I am saying? Built-in electric field. Built in. Because it has been built in the semiconductor itself. So built-in electric field has been developed. Now if there is some electric field, what will happen? It will put some force on the electrons. So let's just say there was this electron, right? This electron is present in the presence of electric field. This is the direction of electric field. This is the direction of electric field, and this is the electron that is present. What will happen? The electron will move in this direction. So first electron started moving from left to right. Electron started moving from left to right because of the concentration gradient. Now when they started moving from left to right, what really happened was there was an electric field built up. Now what this electric field did? This electric field said that go here. And if electrons are moving in this direction, then what will happen? If electrons are moving in this direction, there will be a current flow. That current will be known as drift current. So electrons are moving in this particular direction. Electrons are moving in this particular direction. So this will be the drift current you will be getting. So there are two current components. One is the drift current. And what was the direction of diffusion current? Because of the concentration gradient, electrons are moving in this direction. So what was the direction of a diffusion current? Electrons are moving from left to right. So direction of diffusion current would be from right to left. So this was the direction of diffusion current, and this is the direction of drift current. Both of the currents will be equal to each other and they will perfectly cancel out each other, and the total current would be 0. So when you are having this kind of a non-uniformly doped n-type semiconductor, you thought that, sir, here there is more concentration, here there is lesser concentration, sir, I will get some current because electrons will move from higher concentration to lower concentration. So yes, electrons started moving and you are getting the diffusion current. But what really happened was, when they moved from higher concentration to the lower concentration, this side became positive, other side became negative. Because of that, there was a built-in electric field. Now what this built-in electric field did? This built-in electric field said that if there is some electron present, go in the opposite direction. So electric field is saying that electrons to move from right to left, and if electrons are moving from right to left, then there will be another current. And why I am calling it as a drift current? Because this current is coming because of the electric field. Why I called drift current? Because this current came because of the built-in electric field. So this is associated with built-in electric field. That's why I am calling it as a drift current. So there was a drift current as well, there was a diffusion current as well. Both are perfectly cancelling out each other. The same scenario I am going to explain in p-type semiconductor as well. So let's understand the same scenario in p-type semiconductor. So let's take this semiconductor. The complete EDC is given by me on YouTube itself. Okay, so you will surely love it. You will see a complete different way of EDC. So if you are coming back for 2027, then if you are someone who is in third year and you feel like that, sir, I will come back for 2027, then try covering EDC from there. There are a lot of good educators of EDC, but when human being will teach EDC, you will feel something different. Okay. So here there is more concentration, here there is lesser concentration. What will happen? Holes will move. If holes are moving in this direction, then what will happen? Diffusion current will flow in this particular direction. This is the diffusion current that is flowing. Right. Now if holes are moving in this particular direction, that means holes are leaving. What are holes? Holes are the positively charged particle. They are having a charge of 1.6 into 10 to the power minus 19 coulomb. Positively charged particle. That means positive charge is going. Positive charge is going out. That means this particular side will become negative, and positive charge is coming in. This particular side will become positive. Here negative charge was going out. Negative charge was going out. So this particular side became positive, and negative charge is getting in. This particular side became negative. Here positive charge is going out. This side became negative, and here positive charge is coming in. This side became positive. What really happened? From positive to negative, there will be a built-in electric field. So now an electric field has built up. So inside the semiconductor, electric field has built up. Now this electric field will influence some holes. So there is this hole present. Now what this electric field will say? Electric field will say that I will put the force on you. And in which direction? In this direction. And if holes are moving in this direction, then in which direction current would flow? In presence of electric field, in presence of built-in electric field, this hole is moving from right to left. Again I am saying, in the presence of this built-in electric field, this hole is moving from right to left. Hole is moving from right to left. What does that mean? That means there will be a drift current. and drift current will be in the same direction of the hole flow. So holes are flowing in this direction. So this will be your drift current. And drift and diffusion will cancel out each other, and the total current would be equals to 0. Is that understandable to you? So this is how we need to solve this problem. What they are talking about? Here electrons are leaving. That means this particular side will become positive. Electrons are leaving. And here electrons are coming in. So this particular side will become negative. So what will be the direction of built-in electric field? From B to A. This is the direction of built-in electric field. So what they are writing down? For x between B to A, the electron drift current. Now they are talking about the drift current, not the direction of electric field. So this is the direction of built-in electric field. So for x between B to A, the electric field is directed from A to B, which is wrong. It is directed from B to A. Is that understandable to you? Why it is directed from B to A? Because here there is more electron concentration, here there is lesser electron concentration. From more to lesser they are moving. For more concentration to less concentration they are moving. That means this will become positively charged, this will become negatively charged. Built-in electric field will be in this direction. And what about this one? More concentration, lesser concentration. So this side will become positive, this side will become negative. So direction of built-in electric field will be somewhat like this. This will be the direction of built-in electric field. So now what is the option? For x between B and C, the electric field is directed from B to C. Yes, this is correct. For any x between B and C, electric field is directed from B to C. Yes, this is correct. Now what about option D? For x between B to A, the electron drift is directed from B to A. What do you mean by electron drift? So in this particular region, there will be some electron. Now this electron will feel some force because of the electric field. So what this electric field will say? This electric field will say that I will put the force on you in the opposite direction. So electrons will move in this direction. But are they talking about the electron drift? No, they are talking about the electron drift current. So if the electron is moving from A to B, so what will be the drift current? Drift current will be from B to A. So for x between B and A, the electron drift is directed from B to A. This option is also correct. So correct options are A, B, C. Did you understand this question or not? Shall I repeat it? N-type semiconductor, electron concentration, electron concentration. More electron concentration, lesser electron concentration. Electrons will move from less concentration to more concentration to lesser concentration. So this is the direction of electron flow. If this is the direction of electron flow, here also this is the direction of electron flow, what will happen? If for x between B and C, the electron diffusion current is directed from C to B. That means if electrons are moving from B to C, diffusion current will be from C to B. That is correct. Now for x between A to B, for x between B and A, the electron drift current is directed from B to A. So we will talk about the drift current later on. Let's talk about the built-in potential. So this side is losing the electrons, this side is getting the electrons. So this side became positive, this side became negative. Positive, negative. So this is the built-in electric field, this is the built-in electric field. Right? So built-in electric field is from B to A and from B to C. So from B to C, but not from A to B. So this is wrong. What about for x between B to A? What about the drift current direction? So for x between B to A, what about the drift current direction? So this side has become positive, this side has become negative. So this is the direction of built-in electric field. Now this built-in electric field will put some force on the electron that will move opposite. So electron is moving from A to B. That means drift current would be from B to A. Drift current would be from B to A. So this is also correct. The same question you need to solve with the holes. Will you be able to do it on your own, and will you be able to comment down the answer? In place of electron, what there would be? Hole. In place of electron, what there would be? Hole. In place of electron, okay, built-in electric field. So will you be commenting down the answer, or shall I explain it? So this is the hole concentration they have given. What they have given? Hole concentration they have given. So what is the scenario? This is the hole concentration. There are more holes here. So as of now, pause the video and write down the answer. Okay, pause the video and write down your answer. Now you see the solution, because this is a recorded video, no? So I cannot do anything. So now holes will move from here to here. Holes will diffuse, right? And holes will diffuse from here to here. So what they are saying, for x between B and C, the hole diffusion is directed from C to B. No. Hole diffusion current. Okay, sorry, they are talking about the current first. So holes are diffusing in this direction. That means this will be the direction of diffusion current. This is the direction of diffusion current. Holes are diffusing in this direction. So this is the direction of diffusion current, right? So diffusion current is from B to C. So this is wrong, right? Now holes are leaving from here. Holes are leaving from here. So positive charge is leaving, that means this will become negatively charged and this will become positively charged. Here also holes are leaving from here, so this will become negatively charged and this will become positively charged. That means there will be electric field in this direction, electric field in this direction. So built-in electric field is there from B to C, built-in electric field is there. For X between B and C, the electric field is directed from B to C. Absolutely not. Brain fade, it is from positive to negative. Sorry guys, from positive to negative, from positive to negative. So electric field is directed from C to B, not from B to C. Sorry, yeah, it is directed from C to B, not from B to C. And for X between B and A, the electric field is directed from A to B. Yes, it is directed from A to B. Now, in this presence of electric field, what will happen? Holes will feel some force. So if holes will feel some force, they will feel the force in the same direction. So holes will start moving in this direction. If holes are moving in this direction, then what will be the direction of a drift? So direction of drift will be like this. And here also they will feel the force. Where they will move? They will move in this direction. So what will be the direction of drift? Direction of drift will be this. So this will be the direction of drift and this will also be direction of drift. Or you can simply think that, sir, this is the direction of diffusion, this is the direction of diffusion. That means drift will be opposing it. So if this is the direction of diffusion, drift will be in this direction between A to B. So it will be directed from A to B. So for X between B to A, the whole drift current is directed from B to A. That is also wrong. It is directed from A to B. Okay, is that understandable to you? So whole diffusion is directed from A to, sorry, whole drift current is directed from A to B and from C to B as well. Same question, if you have listened to the discussion very carefully, you will be able to solve it, otherwise you will not be able to solve. Let's go to the numerical ones now. But before that, there is a relation between diffusivity, mobility and thermal voltage. Who are the guys? Diffusivity, mobility and thermal voltage. If I ask you who is the biggest hero of Indian cricket in World Cups? Who is the biggest hero of Indian cricket in World Cups? What you will say? Sir, UV Paji. So who will decide that if India is winning the World Cup or not? Who will decide if India is winning the World Cup or not? That is UV Paji. So UV Paji is the decider. There is nothing U, there is mu. And what about V? V is nothing but Vt. So diffusivity is equals to mu into Vt. That's it. So decider is UV Paji. That's it. UV is the decider. Okay. Now for electrons, if I need to write down, so dn mu n into Vt. For holes, if I need to write down, mu p into Vt. Again, like, don't feel like that, sir, there are a lot of formulas. No, I am trying to reduce the formula as much as I can. Otherwise, EDC becomes completely formula based. But at least there is some trick so that you can remember. Or like conceptual part is also there. Or if you say that this is a tougher problem, or if this is a tougher formula, then I have told you the trick as well. J equals to sigma I. And for rest of the things, we have already written down the conclusion here. Only this slide and this slide, that is the conclusion. Rest all are the problem solving skills. Here you understood the meaning of energy. So on top level, it might feel like that, sir, there are a lot of formula, but when you are solving the problem, you would know that, sir, these minimum formula we can apply. This was the question asked in 2025. Try solving it. What is given? Mobility is given. Mu n value is given, which is 0.38. Again, you see the unit meter square volt into second. Diffusivity is given. Sorry, diffusivity you need to find out at 300 Kelvin. So what is the formula? Decider is UV Paji. So what is the value of Vt? Vt at 300 Kelvin. Although value of K and T are mentioned, but I always remember what is the value of Vt at 300 Kelvin. That is 26 millivolt. So at 300 Kelvin, dn is mu n into Vt, which is 26 millivolt. Okay, so in place of millivolt, what you will write down? 10 to the power minus 3. Right, millivolt. So here what you will write down? 10 to the power minus 3, because everything meter square volt into second, so this will also go into volt only. So what is the answer we are getting? So 0.38 into 26, 0. अरे यार ये मोबाइल नहीं चल रहा है. into 26. So 9.88. So 9.88 into 10 to the power minus 3. This is the answer we are getting. But answer will be in meter square per second. You see the unit, centimeter square per second they are saying. No? Our answer is coming into meter square per second. Why is that so? Why it is coming in meter square per second? Because all the values meter square I have taken, volt per second I have taken, here also I have to taken volt. So meter square, volt and volt is getting answer also meter square per second. If I need to convert it into centimeter square, so 10 to the power minus 4 I can take. So answer is coming out to be 98.8 centimeter square per second. So what is the answer you are getting? 98.8 centimeter square per second. This is the answer. Okay. Now secondly, what if the temperature was 400 Kelvin? Actually at 400 Kelvin this mu n value will also change. How it will change, you don't need to care about it. Okay. So let's ignore this question. It will not be asked actually. Mu n value will also change, at 400 Kelvin. Only V2 value will not change. I wanted to say that if mu n remains constant, so what will happen? What will happen with the answer? V2 value will not be 26. What it will become? 26 into 400 divided by 300. So what will be the V2 value you will get? 26 into 400 divided by 300, 34.66. So 34.66 millivolt you will be getting. So this particular answer, in place of 26 you will be putting 34.66. Right? If mu n is not changing, but with respect to temperature as well, mu n changes. Okay, and that changes as T to the power minus 3 by 2 after 300 Kelvin. So all these things you will not be able to remember eventually. So just forget it. Okay, and very rarely these kind of questions are asked. But these kind of questions are asked which we are able to solve at least at 300 Kelvin. Okay, well and good. Let's solve this question. Try doing it on your own first, and then try doing this one on your own as well. Like again, formula based question it is. Very simple formula based. Very simple formula based question. Nothing is there. Electron concentration is varying accordingly this particular profile. What does that mean? That means, sir, if this is my semiconductor, I am calling this as x equals to 0 and this as x equals to anything, like it is there till infinity. Now you don't know, sir, what is this diffusion length? Ignore it. Like somewhat later on you will understand what is the diffusion length, but as of now ignore it. Okay, if you don't know it, ignore it. You just need the value of ln, which is 10 to the power minus 4. So you will be able to use it. So now this is your, what kind of semiconductor it is not mentioned. So let's put this is your electron concentration is going. So it is going from at x equals to 0 it is 10 to the power 15, and at x equals to infinity it will become 0. So this is how it is going. Okay, here it is 10 to the power 15 and then it is decreasing. That means here there are a lot of electrons and then number of electrons are decreasing, and they are becoming very low. So initially there are a lot of electrons. So from more electrons to lesser electrons we are going. Dn value is mentioned, Ln value, Q value is mentioned. You need to find out the diffusion current, electron diffusion current. What is the formula of electron diffusion current? Formula of electron diffusion current. Why I am putting x here? Because it could be a function of x as well. Let's differentiate and we will get to know. What is the formula of diffusion current? Just write down the formula. Sir, I remember J equals to sigma I. Sigma was n q mu E. Sir, Q remains as it is. In place of mu, D will come. So Dn, we are talking about the electrons, and E is not even there. In place of n, this particular thing would come up. So this is my diffusion current for electrons. Okay. And why I am putting this as a function of x? Because Q value I already know. 1.6 into 10 power. Let's put it Q only. So Q value I already know. Let's put it Dn only. Now what is the value of d by dx nx? What is the formula of nx here? Nx is nothing but 10 to the power 15 e to the power minus x by ln. Now when you differentiate, what answer you are getting? Can you do the differentiation? E to the power minus x by ln, it will remain as it is. Ln will come downward. Negative sign will also be there. 10 to the power 15 as it is. E to the power minus x by ln. Now is it coming out to be a function of x? Q value will be constant value, Dn value will be a constant value, Ln value already know. This is a function of x, no? So yes, actually it is coming out to be a function of x. The diffusion current is coming out to be a function of x. So this is the answer we are getting. Now we need to put the value of x equals to 0, x equals to 10 to the power minus 4, and x equals to infinity, you will get the answer. Nothing else. Now simply you need to put the data. So let's try putting up the data. First find it out in terms of x. So what is the value of q you are getting? 1.6 into 10 to the power minus 19. dn value is 25. Just notice the unit. Q is in coulomb, dn is in the centimeter. So everything is going in centimeter now. As of now, everything is going in centimeter. Divided by ln. Ln is also in the centimeter only. So everything is going in centimeter. So ln is also in centimeter. What is ln? Ln is 10 to the power minus 4. Okay. Then 10 to the power 15 is also there. 10 to the power 15 is also there. E to the power minus x by ln. What is the value of ln? It is also going in centimeter. Always remember, everything is going in centimeter only. So this is also going in centimeter. So can we solve it? 10 to the power 15, 15. So 25 into 1.6. 40. Okay. Minus 40. And let's see, is there anything like this was in centimeter, centimeter, coulomb, centimeter, everything is fine. That means the answer would be coming in ampere only. Why is that so? Because centimeter, centimeter is getting cancelled out, no? dn was having centimeter square divided by ln, centimeter is there, right? So the centimeter, centimeter got cancelled out. This is q, which is in coulomb only. Now 10 to the power 15, 10 to the power 15 centimeter cube is there. So this will also get cancelled out. So eventually, like, what will be the final answer? Final answer will be in ampere only, no? Because centimeter is not the unit of current. If the final answer was in meter, then you would say that final answer would come out to be in centimeter. But now the answer would come out to be in ampere only. Are you able to understand this point? That who is the problem? The problem is this centimeter, no? This guy is the problem, no? Centi. He is the problem. So eventually your answer is not to centimeter, your answer is in ampere. If it was in ampere per, yeah, sorry guys, one more thing, this answer is in ampere per centimeter square. This answer is coming out to be in ampere per centimeter square. Are you able to understand this point? 10 to the power 15. So this is the diffusion current density, no? So ampere per centimeter square. Sorry guys, because this is the diffusion current density. So ampere remains ampere only, because here there was coulomb. Coulomb was there. Somewhere the point is only centimeter is the issue. So here also the area will also be in centimeter. Rest all is not an issue. So ampere will be ampere only. This will become centimeter square. Okay. Multiply with e to the power minus x, 10 to the power minus 4 centimeter. This is the diffusion current you are getting. Now put the different values of x. I hope I have done the calculation correctly. This is 10 to the power. Now you notice there is already a negative sign we are getting. We did not use the negative sign here, but we are getting a negative sign here. What does it is showing? Let's put the values, then I will let you know what does it is showing. So at x equals to 0, what you will be getting at x equals to 0? Minus 40 ampere per centimeter square. At x equals to infinity, or at x equals to 10 to the power minus 4 centimeter, what you are getting? So this will become e to the power minus 1. So 40 divided by e, 14.71. So it is getting minus 14.71 ampere per centimeter square. And at infinity, what you are getting? 0 ampere per centimeter square. Can you draw the graph? Graph of current. Starting with minus 40 to 0. Minus 40 to 0. This is the graph of current, right? This is the graph of diffusion current with respect to x. What is the meaning of minus 40 current? Look, here there was lesser concentration, right? Here there was more concentration. Here there was lesser concentration. So electrons will move in this direction. That means diffusion current will be in this particular direction. Now someone would say that sir, total current would be 0, no? But they are not asking the total current. They are asking the diffusion current only. What they are asking? They are only asking the diffusion current. They are not asking the total current. They may ask the drift current as well. Drift current also I can find out. They can ask the diffusion current as well. Total current I already know that it will be 0 only. Why it will be 0? Because there is no external bias. So that will be surely 0 only. But as of now they are asking only the diffusion current. So diffusion current component I have find out. So now what is the direction of diffusion current? The opposite to the movement of electron, no? So this is just showing the direction. Negative sign is just showing the direction. Here I did not use the negative sign. It is coming by default on its own. So what it is showing? That current from minus 42 it is coming out to be 0. And minus 40 is just showing the direction. Direction is like this. Is that understandable to you? So minus sign is not important. In your examination, like answer will not be written that sir, one option is plus 40, one option is minus 40. What the answer would be written? Answer would be written that current is 40 ampere per centimeter square from x equals to infinity to x equals to 0. Will you be able to understand it? Yes, sir. It is flowing from right to left. So direction of current you will be able to determine by the concept. What does the concept say? That electrons will move from higher concentration to the lower concentration. The current will be flowing in the opposite direction of the electron flow. So current will be flowing in the opposite direction of the electron flow. So if electrons are flowing in this direction, current will be flowing in this direction. So they can ask you the direction, just like this question. So there they ask the direction. So here you don't care about positive negative sign. I don't care about that. Positive, negative, all these things I don't care about. What I care about? I only care about the direction. Okay, and the magnitude. So current is 40 ampere per centimeter square, directing from x equals to infinity to x equals to 0. Understandable? Okay. Similar question for p-type semiconductor, but this time you need to find out the concentration at a particular point. Try doing it on your own. You can do it. If you are good enough with mathematics, this is completely based on mathematics, and you can see that this time concentration is decaying linearly, decreases linearly with position x equals to 0. So just draw the semiconductor x equals to 0 to x equals to 0.1. Somewhere there will be 0.05. Draw the semiconductor, how the concentration is dropping. The concentration is dropping linearly. So if there was some concentration here at x equals to 0, the concentration is decreasing linearly. That means here there was more concentration, here there would be lesser concentration. That means here there were more number of holes, more holes, right? And here there is lesser holes. So this is your whole concentration graph with respect to x. Now what is the formula of current? The formula of current is, so Q remains as it is. In place of mu, dp is coming, and here dpx by dx. But I told you for holes there will be a negative sign, and you will by default understand why this negative sign is coming. Just solve the problem. Now diffusion current value is given, right? The measured hole diffusion current density is 20 ampere per centimeter square. They are saying that this current is constant. This is not a function of x. They are saying that it is the diffusion current density that is 20. It is not a function of x. Isn't it pretty obvious? Why it is obvious that it will not be a function of x? Will q be a function of x? No. Will dp be a function of x? No. Who can be a function of x? This value can be a function of x. See the previous problem, no? This q was not a function of x, dn was not a function of x, this was the function of x. Why this was a function of x? Because slope was changing here, no? Here there was more slope, here there was lesser slope, then slope became 0. So slope was the function of x. When you find out dnx by dx, that was coming out to be a function of x. Here what is the slope? When it is decaying linearly, what kind of graph it could be? Px could be some minus kx plus some m. When you find out its a differentiation, what you are going to get? You are going to get minus k, which is a constant value. Linear decreasing graph is there, no? So that means slope is constant here. If slope is constant, that means this value will also be constant. So if this is constant, this is constant, this is constant, what does that mean? This current is constant only, right? Understandable? So slope is constant, right? And what if it was straight? Then what would be the answer? The diffusion current would be 0 actually. Why is that so? Because there is no slope. So this slope is constant, this slope was already changing. This slope was already changing. But this is constant one. So what you are getting here? Minus q, dp value is mentioned or not? dp value de bhai, nahi di. What he did? He gave the mobility. Mu p value he have given. What is that? 550 centimeter square volt inverse second inverse. So can I find out the value of dp? Yes sir. Decider is Yuvraj Paji. Right? So what you will be getting? So at room temperature I need to get the value of Vt, that I know that 550 multiply with Vt. So what that would be? And everything is going in centimeter, right? So Vt will be, let's use the exact value, or let's just use 26 millivolt. 26 millivolt. So what is the answer you will be getting? 550 into 26. 550 into 26 divided by 1000. If any other value is mentioned, then pick up that value. Okay, here I did not mention the value of Vt. Let's just say in the examination this was mentioned. It will be mentioned there. Okay, 26 milli electron volt, this was mentioned. Sorry, 26 millivolt, this was mentioned there. So I can use this value. I am getting 14.3 volt. Okay, 550 into 26 divided by 1000. So 14.3, not volt. Whatever the unit is, I don't care about the unit. Okay, so whatever the unit is, I don't care about the unit. I just know that everything is going in centimeter, because I am using mu p value here, which was in centimeter only. So everything is going in centimeter. minus 1.6 into 10 power minus 19 into dp. dp is 14.3. This is also going in centimeter only. dpx by dx. So what is the answer of dpx by dx you are getting? 20 divided by 1.6 divided by 14.3. So we are getting 0.87 into 10 to the power 19. Okay, this is the slope we are getting, right? This is the slope we are getting. Can anyone tell what will be the unit of this slope? It will be centimeter to the power minus 4, because you see the carrier concentration would have been given, no? Somewhere the concentration would have been given. Look, whole concentration at x equals to 0 is given. That is 3 into 10 to power 18 centimeter cube inverse. So this will always be given in per unit volume divided by another length. So 1 by centimeter cube divided by centimeter. What you will be getting? 1 by centimeter to the power 4. So this will be centimeter to the power minus 4. Understandable? Although it is not important. So this is the slope you are getting. Along with there is already a negative sign. Let's just say I forgot this negative sign. So when I solve this particular problem, I go to know that the slope is coming out to be 0.87 into 10 power 19. And when I see this particular graph, I already know that slope will be negative. So if slope will be negative, I forgot the negative sign. So by default, I will put the negative sign here. Is that understandable to you? Are you able to understand what I am saying? Okay, actually this problem has been framed in a wrong manner by me. Okay, because it is decaying by a very huge amount, which is not possible. So this will become negative. So in place of 3, you do here, you change this 3. Okay, in place of 3, what you put here? You put 12. Otherwise the question will not make much sense. Okay, or just put this as 3 only, just make this as 19. Or will it make sense? 0.05 centimeter, no? 0.05 I will multiply. So 5. Yeah, it is fine. It will make sense. Don't worry. So let's not do anything else. Let's keep it 3 only. Let's keep it 3 only. So this is the slope that I am getting. Is that understandable to you? Slope is clear to you. Minus 0.87 into 10 to the power 19. Right? So for this particular graph, the slope is clear to you. Let me draw the graph again. Now it is completely mathematics. Like there is very rarely some EDC is used here. Only mathematics is used. Now this value is 0. This value is 0.05 centimeter. This value is 0.05 centimeter. What is this value? This value was given as 3 into 10 to the power 18. 3 into 10 to the power 18. You need to find out this value. Let's just call this value as alpha. Now you know the slope of this particular line. The slope of this line is minus 0.87 into 10 to the power 19. So can you do the calculation now? What will be the calculation? Slope is given, right? Slope is given. You need to find out the point. y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. 0.05 centimeter minus 0. That would be equals to minus 0.87 into 10 to the power 19. So what is the value of alpha you are getting? This will be multiplied with 0.05. So 0.87, or you can say 8.7, right? 8.7 into 8.7 into 0.05. 0.435. This is coming out to be 0.435 into 10 to the power 18 plus 3 into 10 to the power 18. 0.05 centimeter I have multiplied here. I go to know that it is coming out to be minus 0.435 into 10 power 18. This calculation you have to do. Okay, there is no shortcut. This calculation you will have to do. So what I did here, I just made it 8.7 into 10 power 18. 8.7 into 10 power 18, that will be multiplied with 5 into 10 to power minus 2. Or 8.7 into 10 power 18 will be multiplied with 0.05. So everything is going in centimeter. The centimeter is not required. Everything is going in centimeter. So 8.7 into 0.05. 8.7 into 0.05. You are getting 0.435. So 0.435 into 10 power 18. Then just add this particular part. So 3 minus. So 2.565 into 10 to the power 18 centimeter cube inverse. This is the value that we are getting. Is that understandable to you? Is this particular concept is understandable to you? Simply just current value was given, why it was constant, why it was not a function of x, why it was uniform, that is also understandable to you. Just find out the value of slope, then it is mathematics. After the slope, it is completely mathematics. Okay. So then there is a mathematical part that we have done, right? So this is the second numerical that we have solved. Now observation, that same observation which I explained here. Actually, what I thought was that first I will explain this diffusion only, and then I will explain the concept of drift. But here only when I saw that concept of drift is also coming into action, so I explained it here only. But let's explain it again. Okay, let's do it again. So what will happen? Electrons will diffuse in this direction. If electrons are diffusing in this direction, then what will happen? There will be a diffusion current in this direction. And if there is a diffusion current in this direction, so this is the diffusion current. What will happen here? If they are diffusing in this direction, then what will happen? Electrons is going out. That means this side will become positive, and electrons are getting in. This side will become negative. That means there will be a built-in electric field. Now, because of this built-in electric field, what will happen? Because of this built-in electric field, some electron will feel the force. Electron will feel the force in the opposite direction. Electron will feel the force in the opposite direction. Now, if electron is feeling the force in the opposite direction, then what will happen? If electrons are moving in this direction, then what will happen? There will be a drift current in this particular direction. And both drift and diffusion will cancel out each other. What is the value of diffusion current? Like, can I say I diffusion would be equals to minus I drift? Or can I say simply, what is the total current here? Or simply it is very simple, no? Like I diffusion would be equals to I minus I drift only. Why minus I drift? Because both are in the opposite direction. Similar thing would happen here. Holes will diffuse in this direction. That means positive charge is going out. This side will become negative. This side will become positive. Built-in electric field will be there. What this built-in electric field will say? Built-in electric field will say that I will put the force on hole. Hole will move here. If holes are moving here, previously holes were moving here, so there was a diffusion current in this direction. This was the diffusion current. Now, if the holes are moving from right to left, then what will be the diffusion current? Sorry, what will be the drift current? This current is coming because of the built-in electric field. So if there is a current which is coming because of the electric field, that is known as drift current. So here also I can write down I diffusion equals to minus I drift. So what I will get here? What is the value of diffusion current here? Area will be multiplied with both of them, right? Diffusion current I am writing down. But we remember the formula for diffusion current density. What was that? Q dn dnx by dx, right? And then multiply with the area. Here what do I remember? J equals to sigma E. That will also be multiplied with the area. What is the value of sigma? N Q mu n E. In place of E, what I will write down? Built-in electric field. This is not the external electric field. This is the built-in electric field, right? So what is happening? A and A is getting cancelled out. Q and Q is getting cancelled out. Now dn divided by mu n. Dn divided by mu n and dnx by dx. Here in place of n as well I should put nx only, because we are talking about the holes. We are talking about the electrons. They might be a function of x. So I should be putting nx here. So what I should be doing? Nx here. What I will be getting? This is the formula of built-in electric field I am getting. Do I need to remember it? No. In the examination, if they ask you what is the built-in electric field, will you be able to solve it in this manner? That sir, drift and diffusion will cancel out each other and they will be opposite to each other. Drift, if they are asking the direction of built-in electric field, you will be able to tell. If they are asking the magnitude, then what you will do? Just equate both of the currents, job done. Although there is a negative sign here, here also there will be a negative sign, but this negative sign doesn't matter. This negative sign is of no use for me. Why is that so? Because I know the direction already. I just need the magnitude now. So magnitude I will be able to find out. So do I need to do any calculation or anything like that? No. I am not doing any calculation. Okay, I will simply equate them. I would know that A and A will get cancelled out, Q and Q will get cancelled out, dn divided by mu n. What this would be equals to? Can anyone tell? What this would come out to be equals to? thermal voltage, Vt, right? E built in would come out to be dN by mu n. What that would come out to be? Vt. So Vt by Nx, d Nx by dx. Negative sign you don't need to care about. Decider is U upon G. So d by mu is Vt only. There you go. So for finding out the built-in electric field, what they need to do? They need to give this expression only. Basically, in this question, in this particular problem, they could have asked, what is the built-in electric field? What will be the answer? Sir, not in this one. In this one, they could have asked, what is the built-in electric field? What will be the answer? So that would be, I am not remembering this formula. I will derive it. In the examination, I will derive it in this manner. I am not remembering it. Sir, answer would be Vt by Nx dNx by dx. And then there is a negative sign as well. Negative sign doesn't matter to me. I already know the direction. What will be the direction? Sir, electrons are moving in this direction. That means electrons are leaving here. This will be positive. This will be negative. So this will be the direction. Direction will be from x equals to 0 to x equals to infinity. I only care about the magnitude now. What is the value of Vt? Room's temperature 26 millivolt divided by Nx. What was Nx? Nx was 10 to the power 15 e to the power minus x by ln, right? 10 to the power 15 e to the power minus x by ln. Now what is the differentiation dnx by nx? Like simply differentiation of this. What that would be? 10 to the power 15 e to the power minus x by ln multiply with 1 by ln. Negative sign would also come up, that is cancelled with this particular negative sign, right? Negative negative got cancelled out. Is that understandable to you? So e to the power minus x, this is getting cancelled out. 10 to the power 15, 10 to the power 15 is getting cancelled out. I have simply differentiated this nx, nothing else. So 10 to the power 15 was constant, e to the power anything will be e to the power anything only, just that 1 by ln will also come. So differentiation you know, 10 to the power 15, 10 to the power 15 got cancelled out, 1 by ln. Now what will be the answer? 26 into 10 to the power minus 3 divided by ln. What was the value of ln? That was 10 to the power minus 4. So what is the answer you are getting? 260 volt per centimeter. Okay, what is the unit of electric field? That is volt per meter. But here all the calculation is going in centimeter. Why is that so? Because I have put ln in centimeter only. This was in centimeter, ln was in centimeter. So I have put ln in centimeter. So 10 to the power minus 4 centimeter. So answer would be 260 volt per centimeter. This is the built-in electric field. So this question could also be asked in the examination. You will be able to find it out. Built-in electric field, right? Similarly, here as well, you don't have the expression of Px, no? Actually, we don't have the expression of Px. Although we can find it out, but it will be a bit like calculative part. So here as well, you can find out the value. Similarly, in this particular scenario as well, what you can do the same thing. Diffusion equals to drift. What you will do? AQ dp, AQ dp, dpx by dx. Already there would be a negative sign here, but I don't care about it. Minus a, minus sign is already there. A sigma e. What is sigma? Sigma is unique. NQ mu, NQ mu, and then built-in potential. So what will happen? A and A will get cancelled out. Q and Q will get cancelled out. dp by mu p will come. That will become Vt divided by px. Negative negative is getting cancelled out. dpx by dx. Are you going to mug up the formula? Absolutely not. So this is that built-in electric field that we are getting. Okay, it could be a function of x, it might not be a function of x. Here it came out to be not the function of x. In this particular problem, it came out not the function of x, but it could be a function of x as well. In this problem, built-in electric field will be a function of x or not? In this particular problem, it will be a function of x or not? Can you think about it? In this particular problem, built-in electric field, I am not asking you to find out. I am just asking that will it be a function of x or not? Yes, it will be a function of x. Why is that so? Because sir, this Vt will be constant. This Vt will be uniform. It will be a fixed value, 26. This is also a fixed value. No? But Px will be a function of x. So fixed value, function of x. That means whole function will become a function of x. So for the second problem, for this problem, it will be a function of x. Although not a matter of concern, but the only concern is that if they ask the value of built-in electric field, will you be able to find out? I know there is mathematics involved here, but not very tough mathematics is involved. Easy mathematics is involved. Easy mathematics you can do for sure. So this particular easy mathematics you can do for sure. Built-in potential is coming out to be Vt by Nx dnx by dx. Do you remember the formula? Do I remember the formula? Absolutely not. No one remembers the formula. They can simply put built-in electric field they are asking. That means I will equate the current, I will get the value of built-in electric field. Okay. If there is electric field, that means there will be potential as well, which is very important. So what concept comes out? Concept of built-in potential. Concept of built-in potential. So this formula is very important. Okay. I am not going to show you the derivation, although you can do the derivation. What will be the derivation? Derivation will be very simple. What do you know? That sir, what is electric field? If there is electric field, that means there will be potential as well. So from here, sir, if I find out the Vx value, what it will come out to be? Minus integration. This is the differentiation, no? So you take the integration, minus integration from minus infinity to x. Minus infinity to x. E built in x dot dx. Right? So all this thing you do, then the formula of built-in potential will come out to be, simple formula is there. Potential it is, that means answer will be in volts. Do you know any quantity which is having the unit of volt? A fixed quantity. Vt is something is coming, no? So in this particular answer as well, here also Vt will come. Very important formula it is. Ln higher concentration divided by lower concentration. Ln higher concentration divided by lower concentration. Higher concentration divided by lower concentration. Lower concentration of same, higher concentration divided by lower concentration. You will be able to understand what I am saying. Concentration of same particle. Of same particle. Sir, what is this formula? You will be able to understand, don't worry. By the question you will be able to understand. Again, very important formula. It might be asked in your examination. So is it tough to remember? Absolutely not. Vt ln some concentration ratio you need to take. Higher concentration divided by the lower concentration. Vt into ln higher concentration divided by the lower concentration. This you need to take. See this particular question. What is the meaning of n plus n silicon? Look, this was your n-type semiconductor, no? This was your n-type semiconductor. This was your n-type semiconductor. N-type semiconductor. So here there were more doping, here there were lesser doping. So you can call this area as n plus. This area could be known as n plus, and this area could be known as n. N plus means more doping. Okay. So here there is more doping, here there is lesser doping. Let's just say here the doping is Nd1 and here the doping is Nd2. So what you can say? Nd1 is greater than Nd2. So what I have written here? This is the same thing I have written here. So what will be the built-in potential here? Built-in potential will be nothing but higher concentration divided by the lower concentration. That would be the built-in potential. There you. And same goes for n-type as well. Vt ln higher concentration divided by the lower concentration. Safe or no? So similar thing here. N plus n silicon device is fabricated using donor densities. Nd1 is given. That means basically the scenario is that this was the semiconductor I was having. I did the doping here. I did the doping of 10 to the power 18. Then I did the doping here as well. I did the doping of 10 to the power 15. Because of that, what will happen? Here there is more electrons. Here there is lesser electrons. What will happen? Electrons will start moving. If electrons are starting moving, what will happen? This side will become positive. This side will become negative. So there is a potential build-up. This potential has been built up. This potential is nothing but built-in potential. They are asking the value of this particular built-in potential. What will be the value of this particular built-in potential? What that would be? Vt ln. This is the gate PIQ only. Okay. This is the gate PIQ. Sir, Vt, this value I already know, 25 millivolt. Ln higher concentration 10 to the power 18 divided by lower concentration 10 to the power 15. Just another thing to notice here is that here I am putting the concentration of electron only, and here also I am putting the concentration of electron only. So electron concentration divided by the electron concentration. So when I say same particle, that means electron divided by electron. Hole divided by hole. So electron divided by electron. So this will be the answer. What is the value of Vt? 25 milli ln 10 to the power 3. So that will be the built-in potential you are getting. So 25 milli 10 to the power 3. So 3 10 to the power ln into 25 milli. So 0.172. 0.173 volt. This is the built-in potential we are getting. Is that understandable to you? Okay. Higher concentration divided by the lower concentration, 10 to the power 18 divided by 10 to the power 15. Vt value is already there. It is not very tough to remember this formula. Try solving this question on your own. I need to take a break because again it's been longer hours. Okay. So I will take some break. You try solving this question. Very simple, very straightforward. Again it is a gate QIQ. Again it is a gate QIQ. Same thing, higher concentration divided by lower concentration, Vt. That's it. So without even writing down anything, you can get the answer. 10 to the power 2 ln into 0.025. Answer would come out to be 0.115. That's the answer. What will be the built-in potential? Built-in potential will simply be Vt ln higher concentration divided by the lower concentration. Just make sure one thing, whole concentration divided by whole concentration. Na2, Na1. So 25 into 10 to the power minus 3 ln 10 to the power 2. You can do the calculation. You are getting the answer to be 0.115 volt. This is the built-in potential you are getting. Well and good. Okay. Let's make the PN junction now. Okay. So what is this PN junction? That we will study, but after a break. Or shall I make the second part for this? Like I will see the response of this one within 2 days. I will upload the video within 2 days. Then I will see the response, and based on that, today itself I will bring the second part as well. Okay. So I will make the second part where we will make the PN junction. So, but I need to see the response. Are you guys are having some energy to learn more, or that's it? Like it might happen, no, that sir, after some days only we are having the examination, so we might not be having some energy. So first you complete this lecture, then you let me know if you guys are having the energy. Then I will make the next lecture as well. Okay. So within today you complete it. You let me know that yes sir, we are having the energy. Then what I will do, I will bring another lecture as well. Okay, so now I will add up the course promotion video. In this course promotion video, there is an error from my end. Actually, I have said that I will be taking control and mathematics next year, but actually I will be taking this year only. So all the EC course subjects will be taken by me, whether it is network, analog, digital, EDC, communication, signals, control, mathematics, aptitude, everything. All the 10 subjects will be taken by me this year. Okay, only 2 subjects are left. Rest all are already taken by me. So this year, control and mathematics also I am going to take. Okay, so I will add up the course promotion video. What all are the features are there? So that video I will add up now. So for today, this session is ended. I will see the response, and based on that, we will see what we need to proceed. Okay, so first you complete this video, then only you comment down that sir, yes, I am having more energy to learn more topic. I can understand PN junction as well, so I can make another part of it. Okay, yeah, thank you very much. Happy learning.